Hi students, welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. So yes everyone, how are you and how's your preparation going on? Everybody in the chat box. Am I audible? Am I visible to all of you? Am I audible? Am I visible? If yes, then thumbs up in the chat box if I am completely audible and visible to you. Right? Okay, Diksha ma'am Dosa. Wow, what a name you have. Okay. So yes, Nikki, Niku, Ashu, Herberine, Diksha. So many Dikshas in the chat box. Bhargavan, Mandar, Vishnu, Harshit. Yes, how are you all? How are you all? Firstly, so students, this is my first class on Vedantu JEE English. So firstly, let me introduce myself. Right, so those students who don't know me, students, I am a chemistry teacher and I have done my BSc in chemistry, I have done my MSc in chemistry, right, specialized in organic chemistry, but I teach all the subjects physical, whether it's inorganic or organic. Reason being because I have done it in detail in your graduation, in my graduation. Yes, and I have also taught, I have basically experience of 7+ years, right, and I'm very excited to teach you all. Shah sir told me that, okay ma'am, why not teach Vedantu JEE English students? I was like, yes, I'm very excited for that. But so sorry about the last thing because last lecture got cancelled because my health was not fine. So I decided that, okay, I'll take the class on Sunday and students will also be free because at that time Diwali was there, right? Most of the students were busy, occupied in celebrating festivals, right? So I said, okay, let's celebrate that. Let's celebrate Diwali first, and after that on Sunday I will take your class. And today I am here. So how are you all? Yes, very good evening, very good evening. So students, today we are going to do alcohol, phenols and ethers. Now firstly tell me, are you well aware with GOC, right? Very important thing of your organic chemistry. If you ask me, ma'am, what is basically organic chemistry, right? So organic chemistry is totally dependent on the GOC, right? It is dependent specially of, if you talk about JEE mains and JEE advanced, right? The reactions are going to be same only. But the way they ask you questions in NEET and in JEE Advanced is totally different, right? Because in JEE Advanced questions, there will be application of rearrangement of carbocation, GOC, inductive effect, hyperconjugation effect, ring expansion, ring contraction. All of these things will be applied in your questions, right? That is why these concepts are very important for you, right? So I would advise all of you to go through the GOC again and revise that GOC again, right? Because it is very important, right? In between the questions itself, when I'll be solving the question, PYQs we will do some extra questions, we will do the basic reactions. So I'll tell you how to apply GOC in your reactions, right? What is the application, right? So mostly questions that I have picked out, they are based on not only the reactions directly, direct questions you can do that, right? But the problem the students face is when you have to apply GOC in your normal reactions, right? So we'll do those kind of questions today. Okay, so everybody, we will firstly complete our theory part. In between, we will be doing our questions. So are you all ready? If you are ready, then green hats in the chat box. Right, if you all are ready, my symbol is green hearts, okay? Those students who are studying from me for the first time, green hearts is my symbol, right? And some students call me by Dosa ma'am because I love dosa, right? So some students call me Chintu ma'am, a name given by students, right? So you can call anything. You can call Diksha ma'am, Chintu ma'am, Dosa ma'am, anything what you like, right? Okay, green hearts in the chat box, everybody. Very good. Duration. Okay, that's a good question, right? Duration, I will try to keep like in that manner so that we do everything in detail, right? I don't want to skip anything because of that duration, right? So my total focus is on completing things in detail with questions, right? Duration, I will try to make that duration so that you are also able to see the recorded version after that, right? Okay, I will not make it boring for you, right? Okay, yes. What about haloalkanes, halorenes? I think students that you have already done on this channel, right? You have already done on this channel. I checked your playlist. right? Those chapters that are remaining, I am picking out those chapters. So mostly organic is remaining. Till haloalkenes, haloarenes, you have already completed that, right? Ma'am, adjust camera. What happened to the camera? It's fine only. It's fine only. Okay, chalo. So now let us start. It's not blurry. It's fine, right? Are you able to see this? Are you able to see this? Right? Okay. Yes, one shot. It is a one shot. We are going to complete full lecture today itself. Okay. So now let us start the session. Let us start the lecture. So as the name says, it is alcohol, phenol, and esters and ethers. Alcohol, phenols and ethers. So basically, firstly, we need to know the function group of that, right? So what is the functional group of alcohol? Alcohol, very simple, ma'am. Function group is ROH. That is the function group. If you talk about phenol, instead of this R, you have a benzene ring. That is your phenol, right? If you talk about ethers, now in ether, instead of this H, you will have one more alkyl chain, that is R dash. Now this is your alcohol, this is your alcohol, and this is phenol, and this is ether, and this is ether. These are the three things. So what is common between them? Common thing is that one oxygen is present, which is linked to two sigma bonds, right? And this oxygen has two lone pairs on it, right? And whenever we will study all these chapters of organic chemistry, three things we will study everywhere, right? Three things we are going to study. So first thing is your preparation. How we are going to prepare that? What are the different methods of preparing? What is the mechanism of preparation? What is the highlighting point of that mechanism? All these things we are going to do. Then we are going to study about the physical properties. Very rarely they will ask you questions from physical properties. Mostly they will ask you questions from preparation or chemical properties. The third thing is your chemical properties. Chemical properties. Okay. So these three things we are going to study. So firstly, let us talk about the preparation, right? Firstly, we will talk about alcohols. Then we will talk about phenols, then we will talk about ethers. So first thing is alcohol, right? First thing is alcohol. So for alcohol, firstly let's see the classification. Classification is very simple, very easy. It's just a revision, quick revision I am doing for you, right? So for monohydric, hydric means the number of OH group that you will have, right? Number of OH groups. So if it is monohydric, that means one alcoholic group, that is one OH group is there, right? So it has one OH group here. If you talk about dihydric, it has two OH group, like you have ethylene glycol, a very important compound. Ethylene glycol is a very important compound. You will see this like in some of the questions as well, right? Then we have glycerol. In glycerol, you have three OH group, that is why it is called trihydric. It has three OH group. Hydric means OH, right? And when you talk about polyhydric, it means more than three OH group when you have. That is called polyhydric. Like here you have 1, 2, 3, 4, 5, 6. You have 6 OH groups. So this is called polyhydric, right? This is called polyhydric alcohol. Now, next is if you have to divide monohydric alcohol on the basis of whether it is connected to sp3 hybridized or it is connected to sp2 hybridized, right? So it is same as here we are going to talk about allylic, benzylic, vinylic, right? So I'll tell you what is basically that. So if you talk about allylic, allylic means you have carbon, double bond carbon, and next to this double bond, you have one more carbon which is further connected to OH. That means your OH is not directly connected to the double bond. OH is connected to the carbon which is connected to a double bond. That is called allylic, right? And what is vinylic? Vinylic is It's something like this only, right? Now, here, this OH is directly attached to the double bond. In this, OH is directly attached to the double bond, that is called vinylic compound, vinylic alcohol, right? Now, if you talk about benzylic, ma'am, what is benzylic? Ma'am, what is benzylic? In benzylic, you have this benzene ring, but the by name you can say, ma'am, okay, OH is directly connected to benzene maybe. But no, that's not the right answer. OH is not connected to the benzene ring, but it is connected to a carbon which is connected to the benzene ring. So OH is connected here, right? OH is, I am not drawing hydrogens here. Hydrogens you can easily write, complete the tetravalency. It is H2, it is H, it is H2, this is H2, this is then H, this is H2. So you can easily complete the tetravalency and write down the what is the full-fledged formula, right? Now, next is your aride. If you talk about aride, in this case, your OH group is directly attached. Basically, we are talking about phenol or phenol derivatives, right? Phenol or phenol derivatives. Very good. Now, ma'am, how come they are talking about sp to sp3 hybridization? You just have to check the hybridization of carbon here. That is your alpha carbon. So this is your carbon which is, to which OH is connected, and this is that carbon to which OH is connected. This is that carbon to which OH is connected, and this is that carbon to which OH is connected, right? So let's see the hybridization here. In this case, carbon. Now, when you want to find out the hybridization, a very simple rule is, right, very simple rule, if you have 4 sigma bonds, sigma plus lone pair, right, if you have 4 sigma plus lone pair, that is sp3, if you have 3 sigma plus lone pair, that is sp2, if you have 2 sigma plus lone pair, okay, what I am saying is, if you have 4, then it is sp3, if it is 3, then it is sp2, if it is 2, then it is sp. That is the answer. Okay, so now here I will just write down here that what is my hybridization. It is connected to 2 hydrogens, 1 OH and 1 carbon. That means 4 sigma. That means it is sp3. And what is this? This is again, it is connected to 1 sigma, 2 sigma, 3 sigma with hydrogen. So it is again sp2. What about this one? It is connected to 4 sigma bonds. 1 sigma this, other sigma this, and 2 sigmas are of hydrogen, right? So it will be again sp3. And what about this one? What is the hybridization of this carbon? What is the hybridization of this carbon? That is sp2 or 3. sp2 or 3, everybody? Yes. Yes, everybody. OH group is attached to sp2 hybridization. Very good, Diksha. Carbon that forms a double bond. Very good. Very good. So that is your sp2 hybridized, right? Okay, you should have a knowledge of these things, right, so that you are able to answer the products, because in exam what they are going to tell you, they are going to say these are the reagents, this is the reactant, what is the product that is formed, right? So in the option they can ask you allylic, vinylic, what kind of thing will be asked, right? Okay, so now that was about your vinylic and allylic carbons, right? Now let us talk about primary, secondary and tertiary. Now, for example, this OH is connected to that carbon. Here I am not talking about to how many carbons OH is connected. Here we are talking about the OH is connected to a carbon. I will see this carbon is connected to how many other carbons, right? So here, this is the carbon that we are focusing on, because this is the carbon to which OH is attached, and this is further attached to only one alkyl chain. That means this is 1 degree, that means primary alcohol. If you talk about secondary alcohol, the carbon which is connected to OH is further attached to 2 rings here, 2 alkyl chains, that means connected to 2 carbons, so it is 2 degree alcohol. If you talk about 3 degree alcohol, in this case, you have OH that is connected to a carbon which is further connected to 3 carbons, right? Which is further connected to 3 carbons. So basically it's like this. You have OH here and it is further connected to 3 carbons. If this carbon is further connected to 3 carbons, that is called tertiary alcohol. So now that will be called as, wait a minute. Yeah. So that will be called as tertiary alcohol, right? Okay, so same, let's see with the very good evening students, very good evening Karthik. So now here, what is allylic? According to allylic is what? When your double bond is connected to a carbon, to that carbon your OH is connected. Now we have to divide 1 degree, 2 degree, 3 degree in allylic carbons, right? So now, if OH is connected to a carbon, now this carbon is only connected to one carbon. This carbon is only connected to one carbon. So it is 1 degree allylic alcohol, right? If you talk about this, here OH is connected to a carbon which is further connected to two carbons, this carbon and this carbon, but that means it is 2 degree, right? Because it is connected to two more carbons. That means it is secondary alcohol, right? But the other thing is that this chain, this ring or this a chain that is connected here is basically a double bond. That means it is allylic also, right? 2 degree allylic alcohol. What about this one? What about this one? In this case, this is your OH and here the carbon is connected, which is further connected to 3 carbons. So it is 3 degree. That means it is tertiary alcohol. Why it is allylic? Because ma'am, this OH is connected to this carbon which is further connected to a double bond. That is why it is allylic in nature, right? That is why it is allylic in nature. Yes, allylic. Very good, very good, very good. Yes, Surinder, what is the doubt? What is the doubt? Yes. Okay. Now, next is classification based. This is basically benzylic alcohol. For benzylic alcohol, how to define 1 degree? Again, simple, right? Very simple. You have OH is connected to one carbon, which is further connected to only one carbon. So, it is 1 degree. OH is connected to one carbon, which is further connected to two carbons. So, it is 2 degree. OH is connected to one carbon which is further connected to 3 carbons. So it is 3 degree. Why they are benzylic? Because OH connected to carbon is connected to benzene. Same, OH connected to carbon is connected to benzene. OH connected to carbon is connected to benzene. Right? This is your benzylic 1 degree, 2 degree and 3 degree alcohols. Right? Okay? Wait a minute. Okay, let me see what just happened. Okay. So sorry. No. Wait. What just happened? I hope so. Now it's fine. Right? Okay. Okay. Let me see. Okay. I think now it's fine. Right? Ma'am, please explain hyperconjugation. Yes, I will explain that, right? But this is not a lecture of GOC. This is a lecture of alcohol phenols, right? So I won't be able to explain today, right? Okay? Yes. So now let us talk about this thing. That is, just give me a minute, students. Just give me a minute. Let me see that what is the issue that is happening here. Wait a minute. Yes. Now am I audible? Now am I audible? Yes, students, am I audible now? Okay. So guys, I'm so sorry about this, right? Today, I've asked the team to work on this and they are working on this. So it will take us 5 minutes. Hello, hello, hello. Hello, hello, hello. I think now I'm clearly audible, right? Okay. I don't know why this happens in my class. What is wrong with this board? What is wrong with this? I think the board is feeling little bit scared of the alcohol, phenols and ethers. Okay, so chalo, I'll tell you the classification of phenols here, right? All these things are also mentioned in your NCERT as well. And the common names are also very important for you. So let us see that. First is your monohydric phenolic group. That is your this phenol, that is when you have just one OH group attached here. When you talk about two OH groups, right, and depending upon whether they are attached to ortho, para or meta position, we have three things. Now, what is an ortho position? If you talk about a ring, for example, a group is attached here, right? If next to this group is called this ortho position and next to that is called meta and this is called a para position. So, it is ortho, meta, para, right? OMP, ortho, meta, para, this is the group here. So, now, let us see that, here you have catechol. What is catechol? When two OH groups are attached to the ortho positions of each other, right, next to each other. What is resorcinol? Resorcinol is when your OH group is attached at the meta position to the other OH group, right, to the other OH group is attached to the meta position, right? Yes, yes, it is enough, right? Yeah. So now, what is quinol? What is quinol? When OH groups are attached to para position to each other, that is called quinol. Okay? Right? When OH groups are attached at para position to each other, that is called quinol. Now, let us talk about trihydric OH groups. When you have three OH groups here, right? When you have three OH groups, this is your OH, this is OH, this is OH. Now, two OH groups are placed next to each other, but one is parallel to this group. That means if you talk about this over here, with reference to this OH group here, one is at the meta position, other is at the para position. So that is called pyrogalol. Now, these names are not very important, but yes, you can go through that once, right? These names are most important: catechol, resorcinol, quinol. These are important for you, right? Okay. If you have this OH group and you have two OH groups at the meta position, one OH group at the para position, in that case, it is called fluoroglucinol, right? Fluoroglucinol, right? Okay. Students, what I am doing here, right? We are doing alcohol, phenols and ethers, right? Electron withdrawing, hyperconjugation, rearrangement, all these things are not a part of alcohol, phenols, ethers. That is a part of GOC. Now, firstly, tell me, have you done GOC on this channel or not? Have you done GOC on this channel? Because according to me, I saw that you have done GOC, right? Have you done or not? GOC, inductive effect, hyperconjugation, aromaticity, resonance, dancing resonance, and rearrangement of carbocation. Have you have you done this on this channel? Have you done this? Done? No? Yes. So you can just revise that, right? Let's focus on those things that are not taught on this channel this year, right? I am focusing on those things, right? Okay. Yes, GOC is done. No? You just need to know how to apply the GOC now, right? Okay. So now next thing is we are talking about the preparation of alcohols, right? Preparation of alcohol. So starting with, we have done the classification. Now we are starting with the preparation of alcohols. Don't worry about this blinking. I will sort this out in 10 minutes, right? This will be sorted out in 10 minutes. I don't want to skip today's class, right? I don't want to cancel today's class. I really want to take and I really want to finish this lecture today itself, right? So if you talk about the alkenes, preparation of alcohols from alkenes, so you have so many things here, right? Basically, you have three methods here. What are these three methods? First is from acid catalyzed hydration. You're adding water in the presence of a strong acid like H2SO4, right? So that is your acid catalyzed. Second is hydroboration, oxidation. Third is oxymercuration, demercuration, right? So these are the very, very important reactions from where we are going to prepare. From alkenes, we are going to prepare alcohols. Now, I'll tell you the mechanism, then I'll tell you directly with the trick how to prepare the product, right? Sometimes this will have a different rule, this will have a different rule, this will have a different rule. But in all these cases, you will prepare alkene, you will prepare alcohols from alkenes. In all these cases, you will prepare the same thing, right? But the way it is prepared is different and sometimes the product is also different, right? Okay, so we'll do some questions also based on this. Ma'am, why screen is glitching? Students, I don't know why the screen is glitching. I have no idea on that, right? Screen is glitching and I'm very sad about it because I was very excited for today's lecture. But you know, when you're very excited for something, something bad happens. So always happens with me. Tell me if this also happens with you also. Whenever I'm excited, super excited for something, that okay, this will happen, I'm waiting for that day, right? What happened on Wednesday? I was having 103 fever, 103 fever I was having that day. So I was like, I won't be able to take class today, right? That's why I had to shift the class. So now I was thinking that okay, today everything is sorted, my health is fine, I am also perfectly fine. Now I'm very excited for today's class. Now this happened. Now my board is not fine. My board has 103 fever. Hydroboration, Markovnikov, anti-Markovnikov, very, very good. Yes, that's my life also, right? So I'm really waiting for the team to call me and tell me what to do about this, right? Wait a minute, let me text again. Okay. Okay. Glitch and dosa, ma'am, class, never ending love story. I think I need to break up with this glitch. It's high time I should break up. Okay. So now I just want to restart this, but for restarting I need permission. So just give me a minute so that I can restart this. After restarting this, everything will be fine. I just need that permission to restart the board, right? Otherwise the class will end, right? So I need that permission. I'm just waiting for that. Okay. Yeah. Okay. Hello. Students, just give me some time. It will be sorted in 2 minutes. Okay. Just give me 2-3 minutes. It will be sorted. Right. So there is some glitch that is happening. Right. That's not in my hands. Right. So team is going to do that. So just wait for some time. Right. Just wait for 2-3 minutes. It will be sorted. Share sir teaching. Do you know any channel? Actually, he is the best teacher I have seen. JEE aspiration. Ma'am, I am new JEE aspirant. Okay. Alkyl halides and aryl halides. Students, when you see this channel, right, go to the playlist section, right? From that section, you will see chemistry playlist, right? There we have already done so many chapters. I am completing those chapters that are left, right? Those chapters that we have already done, I am not repeating that, but I will do the revision after once the first priority is to complete the syllabus, right? So organic part is a lot of organic thing is left, like for example alcohol phenol ethers, then you have aldehyde ketones, carboxylic acid, amines, biomolecules. These are very very important chapters from where directly you will see so many questions, right? So firstly our focus is going to that, firstly we need to solve that issue. After that we will focus on other things, right? After completing the syllabus we will do the revision, right? In that revision I'll morely focus on the questions than the theory part, right? Okay, so we'll do the questions plus some theory concepts also. By that, so that we are able to, get prepared for the exam, right? Okay. Yes, it's there in the playlist. I feel. Wait a minute. Let me see if it's there in the playlist or not. Let me see that. Let me see that if it is there. You see the playlist section? There you will see chemistry. Wait a minute. Yes. You can see haloalkanes, haloarenes. Yeah, it is not there, is it? I don't know why I. Wait a minute. Let me see if it is there or not. Okay, it's not there, so I will do that. Okay, if it is not there in your playlist section, then I will complete haloalkanes, haloarenes as well. Okay, yes. No, in JEE means I'll tell you what kind of questions. For JEE means NEET is like a little bit, but yes, they ask you tough questions also. Like I told you that some of the questions are high level as compared to NEET. So yes, that is not entirely. Yes, the topics are same, but the way they ask the question can differ, right? So when I teach NEET students, I teach the PYQs of NEET and the questions that are revolving around the PYQs of NEET exam. When I'm teaching JEE students, I'll teach you, when I'm talking about JEE, I'll teach you the way JEE questions are asked, right? Especially JEE advanced questions are asked, right? Because after JEE, you will have very less time to prepare for JEE advanced, so you should prepare now only, right? So our focus is going to be JEE mains and JEE advanced also, both of them, right? Okay, yes. OMDM addition of water, chalo. Now let us do this. Acid catalyzed hydroboration, oxidation, oxymercuration, demercuration. Basically, you have three kinds of things, right? So when you talk about acid catalyzed hydration, in that case, what we do, we pick up water, right? Then acid catalyzed means, which is going to, what is acid? Acid is going to give us H positive, right? That is pure acid. It is a H positive proton donor, right? So it is going to give us H positive here, right? And you will have the formation of alcohol, right? But here, very important thing is, ma'am, what is the mechanism? What kind of alcohol will be formed? So in this case, the important part is, firstly, you will make the carbocation, then you will do the rearrangement. From that, you are going to solve this, right? Firstly, carbocation, then rearrangement. That is going to be the answer. Firstly, carbocation, then rearrangement. Carbocation, then rearrangement, right? Now, if I talk about the mechanism here, mechanism is very simple. This H positive is going to attack over here and it is going to form the hydronium ion, right? For example, why it is going to attack over here? Because you have H2O. Yeah, it is tough to teach like this. Okay, so this is oxygen. It is having two lone pairs. So now, when H positive is going to attack here, what will happen? And always in mechanism, always remember that your arrow is from more electron density to less electron density. So here you have more electron density, here you have less electron density. So answer will be your hydronium ion, that is H3O positive. That is going to be the answer. Now, this hydronium ion that is having O positive and 3 hydrogens are attached here. This is your electron rich and this oxygen is your electron deficient. So what will happen? This electron rich species, the pi bonds are going to attack here. The electrons and this hydrogen is going to attach to this double bond here. And this electrons of this OH bond is going to shift on the oxygen and you will have the elimination of water. And here you will have the formation of a carbocation. How carbocation? But because in this case, the electrons are going to jump on one side. For example, the electron jumped on this carbon, right? The electron jumped on this carbon. I think too much glitching. Students, just give me 5 minutes, okay? I'll see, because I can't teach in this glitching. I think you also won't be able to understand in this glitching, because when I'm writing, it is disappearing, right? So it is very difficult for me to teach as well, right, in that case. So just give me 2-3 minutes. Studio settings taken care, ma'am, Capto. Okay, so Capto has taken care of the studio settings. Just give me 2 minutes, right? Okay. Hi students, I am back. I am so sorry about that. And yes, Capto, thank you so much. You saved me today. And I really hope so. Now we will not face that problem again. And now let us start the session, right? Let us start the session. The main part we are going to start now, right? Till now we were doing just classification. Right now we are going to start the main part. Okay, everybody? Yes? So everybody, let us start the session again. Now, starting with the preparation of alcohols, right? As I told you, the preparation are going to be from different things. So, firstly, we are going to talk about alkenes, right? So, from alkenes, there are going to be 3 types of preparation. And what was that? 1, 2, 3. From 3 types, we can do that. First is your acid catalyzed. First is acid catalyzed, right? And here we are converting alkenes to alcohols, right? Second is going to be hydroboration, hydroboration, oxidation, hydroboration, oxidation, hydroboration, oxidation. Third is going to be oxymercuration, 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 demercuration, and very important, demercuration, very important, 3 types, right? Very important. So first is your acid catalyzed, right? Okay, first is your acid catalyzed. Let us talk about what is acid catalyzed and how to do it. So in acid catalyzed, right, firstly we will see the mechanism also. This so you already know, ma'am, from alkenes alcohols will be formed. What's the big deal in that? The big deal is the mechanism. So you should understand the mechanism here. What is the mechanism? In this case, acid catalyzed, that means a proton from the acid has donated the proton. Now this proton is electron deficient and your water is electron rich. They will react, this lone pair will accept the H positive and they will make a compound like this, that is your hydronium ion, where oxygen is connecting to 2 hydrogens, and whenever oxygen has more than 2 bonds, that means oxygen having 3 bonds, that means oxygen will have a positive charge on it, right? For example, nitrogen usually form 3 bonds, right? So when nitrogen forms 4 bond, it will have a positive. Oxygen usually form 2 bonds. So when oxygen is forming 3 bonds, it will have a positive on it, right? So this is positive HHH, right? Now, next thing is what you are going to do. Here you have alkene. Now what will happen? Always remember this thing. When you have this double bond, right? So what will happen basically? The electrons are going to jump either on this position or on this position. This I will tell you to where it will jump. I will tell you that, right? Because that is important, to where it will jump. Ma'am, to this position or to this position, right? Now because both are symmetrical, right? I am assuming this carbon is also having both symmetrical things. This is also having both the same groups. Then in that case, it can jump anywhere, right? If it is unsymmetrical, then there is problem. Then we will see to where it will jump. Now I am assuming that both are symmetrical, so it will jump on either side. That means it will be like this. This will be single bond, this will be a negative and a positive. And to this negative, one hydrogen will be, that is liberated by this hydronium ion. How? Because the electrons are going to jump here and this H positive is going to attack here and it will be this. Now you will have the formation of carbocation. That is the main important part here. So write it down. The main important part is formation of carbocation. Formation of stable carbocation is our main thing that we need to do here, right? Yes, you can use sulfuric acid. Mostly we use sulfuric acid only, right? Then we will do the rearrangement. We will do the questions will be based on the rearrangement, right? Then it's not like you will just add OH negative, then okay, this is a this is a carbocation. Let's add OH negative. No, firstly you have to do the rearrangement, then you will see what is the alcohol that will be formed here, right? So main 2 important things here are that firstly you will do the carbocation. For carbocation will be formed, after that there will be rearrangement. Firstly carbocation, then rearrangement will be there, right? Okay, then that will be the answer, right? So carbocation, then you have the addition of oxygen. This again H2O will attack here. Then again what will happen to this side? The electrons are going to jump here, right? Then this H is going to liberate here and hence you will have the formation of alcohol, right? This electrons jumped here and the H positive liberated and hence you have the formation of alcohol, right? Ma'am, do I need to remember the full mechanism? No, you don't need to remember the full-fledged mechanism. That's not what is important for you to understand, that carbocation is formed, after that rearrangement will happen. Now I'll tell you what kind of questions they will ask you in the exam. The questions that they will ask you in the exam will be like this. For example, you have this thing. For example, you have this thing, right? This is the question, right? This is the question. Now they are asking you what will be the answer. Now they are asking you what is going to be the answer. Right? Now you need to tell me what is the answer. First thing I told you, first you need to understand where the electrons are going to shift, which is the carbocation that we are going to form. Right? So either electrons can jump here or electrons can jump here. So two things can happen. If the electrons are jumping to this side, so it will be CH negative and this is CH positive, right? This is PH and this is your CH3, right? To this negative one hydrogen will be attached. This is the carbocation that will be formed. If electrons are jumping on this side, in that case you will have CH, this is CH negative and this is PH and this is your CH, this is your CH3. To a negative, H will attach here, so it will be CH2 and this will be the carbocation. Now you tell me which is the stable carbocation, this or this? Which is the stable carbocation, right? Yes. Tell me students, which is the stable carbocation, this one or this one? This one is the stable carbocation or this one is the stable carbocation? Which is the stable carbocation? Now, here we will have the rule of GOC, right? This is where in the reaction you need to understand the GOC also, only then you will be able to answer things, right? Here we have the rule of GOC, right? What is the rule of GOC? Now you have this phenyl, now you have this phenyl, right? Now to this phenyl, you have the attachment of this carbocation, right? Now to this one, what you have? CH3, right? This is carbocation. We know that which thing is more stable. Because of resonance, this is more stable. That is why we will eliminate this thing. This will not be formed, this carbocation will be formed, right? This carbocation will be formed. Okay. Okay. Now, next is, yes, ma'am can't, yeah, I have reduced the temperature. Now, I just pray that I don't get temperature, right? So, now, what is this? This is your correct, this is your wrong one. Why? Because phenyl will make it more stable because of the resonance. What is resonance? What is resonance? If you talk about this thing, this is your CH2 positive. Here the electrons are going to jump here, then these electrons will jump, these electrons will jump. It will show resonance. That is why this is your correct answer. And to this OH negative will attach. Hence you will have the formation of CH3, CH2, CH, this is OH and this is your phenyl, right? So that is going to be the correct answer. So it's not like you just have to cram the mechanism. You should know how to answer things, right? Okay, how to answer the things. Now, I'll give you one more question based on this, based on the rearrangement. For example, you have something like this, C double bond C, this is your CCH3, CH3, this is H, and yes, and this is CH3, right? As we can see, which carbocation will be more stable? Which carbocation will be more stable? We know that if positive is present here, then it will be more stable. Sorry, if positive is present here, then it will be more stable because a bigger alkyl group will be attached here, right? Here you have a smaller alkyl group. So that is why this carbocation is more stable. Hence, when this bond will break, electrons will jump on this side. It will be CH3. This is C, right? One hydrogen will be present here. One hydrogen will be present here, right? This is your CH, this is your CH. To this negative, you will have the attachment of one hydrogen, then the single bond, then you have this carbon, right? And this will have a positive, then you will have CH3, CH3, right? Now tell me, is that correct or not? Is that correct or not? Should I just attach OH here? What we have formed? Okay, those students were like, ma'am, what you have done, ma'am, please repeat that, ma'am. Directly you have done this. Okay, tell me students, what can happen? Either electrons can jump here or electrons can jump here, right? I am assuming that why electrons should jump here, because in this case, you will have a bigger alkyl group. We are talking about the electron donating power. Whenever we are talking about carbocation, if for example someone is very poor, you are giving money to them, they are feeling very happy, they are feeling stable. So here it is poor, you are donating the electron, that means you are making it stable. So in this case, here the donation will be less, but in this case the donation will be more, right? So in this case, what you will write, here it will be, here it will be. That's why I have eliminated this option, I have selected this option. So answer is CH3, CH, here you will have negative, and that is why you will have a electrons. Wait a minute, electrons should jump here, yes, not here. If the electrons are jumping here, only then we will have the carbocation formation over here. So this is CH, this is CH, this is CH3, and this is CH3. If the electrons are jumping to this side, here you will have negative charge, here you will have positive charge. To this negative charge, you will have the attachment of one hydrogen, right? Now, should I just attach OH here? Should I just directly attach OH here? We are not understanding what you are doing, ma'am. Mandar, then you should see the GUC part firstly, right? That's my advice to you, right? Without GUC, organic chemistry is not like, you won't be able to understand only. JEE means level is not possible, right? JEE level is not possible without GUC, right? You can understand boards level, but you can't, you won't be able to understand this thing, right? Why? Because it's a basic is your GUC. All the things that I am talking about is GUC only, right? So here, what I will do, this is basically my 2-degree carbocation. It is attached to 2 carbons, this carbon and this carbon. So this is my 2-degree carbocation, right? But according to the stability of carbocation, firstly you have 3 degree, then you have 2 degree, then you have 1 degree. Can I make this 3 degree? Can I? Yes. Yes. So I can make this 3-degree carbocation. How I can make this 3-degree carbocation? By the hydride shift. This hydride present here, this hydride over here, this hydride that I am drawing here, this is C, this is H. This hydride will shift to this position, and then what you will have, this is CH3, this is CH2, this is C, this hydride will shift here, it will be CH2, and hence you will have CH3, CH3. Now tell me, what is the degree of this carbocation? Now this carbocation is a 3-degree carbocation, right? Because to this carbon you have 3 carbons are attached, right? So that is why it is 3-degree carbocation. So we will say, yes, this is a stable carbocation. Now we can attach the OH negative group here. So we can easily say that it will become, we can attach the OH negative part here, it will become something like this, that is CH3, CH2, CH2. If you are thinking that in JEE, they will ask you simple question, you are in big illusion, right? So they will not ask you direct question, they will ask you these kind of questions, right? Okay, they will ask you these kind of questions, that they will give you a reactant, then they will give you the reagent, they will ask you the product, but it won't be a simple product that you will directly form, right? There are so many concepts that I have taught you here. Like there are 2-3 concepts directly from GUC that we are applying here. First concept is which carbocation is more stable, to which electrons will shift, right? That is based on different factors like hyperconjugation, inductive, resonance. And then after this, we will do the rearrangement, right? Here what will happen? Rearrangement of carbocation will happen. Rearrangement of carbocation will happen, then you will have your desired product, right? Okay. Okay, students, understood? Understood this? Yes. Now, second is hydroboration oxidation of alkenes, right? If you talk about hydroboration oxidation, Here we use diborane, that is B2H6 in the presence of THF, right? Now, then we use the oxidation part. For oxidation part, we use peroxide H2O2 in a base, right? KOH, right? In a base, we will use this. You will have the formation of the alcohol. Now, here the important part is, here what you have to apply in the questions, that we will use anti-Markovnikov addition, right? That means, what is anti-Markovnikov addition? Anti-Markovnikov addition means your negative part is attached to more number of hydrogens. The negative part, for example, what I am adding here, I am adding OH negative and H positive, right? So this is my negative part. This negative part will attach to more number of hydrogen of the double bond. So this is a double bond, this has one hydrogen, this has two hydrogen. So it will attach to more number of hydrogen, that is this part. Here you don't have to make any carbocation, you don't have to do any rearrangement in this case. This product is direct, right? This product is direct, that you will directly apply anti-Markovnikov addition here. But when we talk about acid catalyzed, there you have to make carbocation, then you have to make the rearrangement, then you will form the product. Here directly you will apply anti-Markovnikov addition, that route. Now let us see what is the mechanism here, why it is so, right? Why it is so? So what is the mechanism? So you have this alkene. Firstly, what will happen? You will have this HBH2. So now, firstly, what will happen? This H positive, right? It is going to, this is electron deficient. It is going to attack here, and you will have the, instead of this H, basically you can just talk about this H only, right? You can just talk about that this is your BH3, right? Instead of it, you can just assume that this is your BH3, right? It exists as a dipolar, but you just assume that this is your PH3. So now what will happen? With the replacement of one hydrogen, you will have the formation of this double bond will break here, and hence you will have the formation of CH3, CH3, CH, CH2, and this will be attached to your BH2, right? And to this part there will be one hydrogen that will be attached. So it will be CH3, CH2, CH2, BH2, right? Then again one hydrogen, basically what you can see in a simpler way, what you can see, this is your BH3. In a simple way, I am telling you what is the mechanism in a simple way, right? This is your BH3, right? Firstly, what will happen? You will react this with alkene, right? This will react with alkene, that is CH3, CH double bond CH2, right? Electrons will jump, right? Electrons, where it will jump, you should have a positive over here and negative over here, right? Or a negative over here or a positive over here, right? So what will happen? When the bond will break here, right? When the bond will break, what will happen? They will firstly replace this hydrogen with this part, this CH2 will get replaced here. This will be CH2, CH2, CH3, like this. Okay, this is what you have formed here, right? This is what you have formed here, CH2, CH2, CH3. Again, what will happen? One more molecule will react here. This will be CH2, CH2, CH3. Again, one more molecule of alkene will react here, and it will replace this. This is CH2, CH2. This is a simpler way of doing this, okay? This is a simpler way, because in this way you will get confused that what is happening, ma'am. So basically, you are adding first molecule, one hydrogen is replaced by this part. Then you are adding one more alkene, then two hydrogens are replaced by this part. When you are adding one more alkene, then three parts are replaced by this part. So again, the third part is this one. So in the end, you will, after reacting three molecules of alkene with the diborane, you will have the formation of this thing, right? This is easy way to remember this. Now from after the oxidation part, this is just hydroboration part. This is not oxidation part. This is hydroboration part. After the oxidation, these bond will break, and you will have the formation of which thing? You will have the formation of what is left out. What you will have the formation of CH3, CH2, CH2, OH, right? So that is your final product that will be formed here. After your, this is oxidation part. This is oxidation part. After oxidation, you will have the formation of this thing. But remember one thing, always whatever is given to you, you will always apply anti-Markovnikov rule. The reason is that your less number of hydrogen part is already occupied with this thing. This less number of hydrogen part is already occupied, right? So that is why you will have only this part, that is your terminal part. That is your terminal part and this is your terminal part. And to this terminal part only you will have the addition of this OH, right? Okay. Now, third is your oxidation, oxymercuration, demercuration. In this part, you will have the formation. Here you will use Markovnikov rule. Here you will use Markovnikov rule, right? Okay, Markovnikov rule is directly used here. That means your negative part is attached to less number of hydrogen. Less number of hydrogen. Negative part is attached to less number of hydrogen. So you will directly attach the negative part to less number of hydrogen, right? This is full reagent, right? That is your HGOAC, right? What is AC? Acetyl, right? Twice. THF presence, right? And then NaBH4 plus in basic medium. You will have the formation of an alcohol which will follow Markovnikov addition, right? Not anti-Markovnikov, this will follow Markovnikov addition, right? So basically, right, let us do the mechanism as well, right? Let us do the mechanism as well. Here, why it is following Markovnikov rule? Why this is not following anti-Markovnikov rule? Because what you will see here, this Hg, right? This Hg is going to attack on this double bond, right? And it is going to form a compound in which you will have the formation of this kind of mercurium ion, right? So now what you will see in the next step, this mercurium ion, so this H positive, it is going to take out electron from here, and the water in the reagent, we also have water, right? We have water here, right? So what will happen in the second step, this water, the lone pair of this water is going to attack here, right? This is how OH will be added, right? So here the water will have attack over here and the electrons are going to move here. There is no formation of carbocation in this case as well. As you have seen in hydroboration also, there was no formation of carbocation. Here also there will be no formation of carbocation. This is taking part in a transition form, right? One bond is going to break here and one bond we are going to add here, right? So this bond is going to break and the electron are going to jump on this part, and hence you will have HGOAC, simple, right? But one O, oxygen is going to attach here. Now this oxygen is connected to 3 sigma bonds. That is why it has a positive. But oxygen is not stable when it is having a positive charge. That is why what will happen, one H positive we are going to lose here. The electrons are going to jump here and hence you will have the formation of OH part here. Now, ma'am, what about this HGOAC? What we will do with this HGOAC? They will just convert, then we will just react this with NaBH4, which is a very good reducing agent. So it will reduce this part to hydrogen, right? So that is the use of all the reagents, right? That is the use of all the reagents, right? That is why it is called oxymercuration, demercuration. Why? Because firstly, you added the mercury here. So it is mercuration, right? Then what you did? Then you demercuration. That means you take out the mercury, that means you take out the Hg from here because of the reduction, right? That is called the demercuration part. So oxymercuration, demercuration, 2 steps are involved, right? Okay. Ma'am, for unsymmetrical, can we use Markov? No. Whenever you have acid catalyzed, I would advise you use carbocation and then rearrangement, because you should have one thought in your mind that whenever I have acid catalyzed, I will always make carbocation and then I will do the rearrangement. In other cases, there is no carbocation formation, right? I'll tell you, I will give you one example that why I am stressing on this thing. Why I am stressing on this thing again and again? Because of some questions, right? For example, you have this kind of question, right? Now, I am using the same reactant. The reactant is same, but First is acid catalyzed, other is oxymercuration, demercuration, third one is your hydroboration oxidation. Now these kind of question you will see in the exam, right? Now I'll be like, ma'am, what will be the answer to this one? I don't understand, ma'am, what will be the answer to this one? Right. Now, let us see the acid catalyzed reaction, right? When you talk about acid catalyzed reaction, what should happen here? This is your benzene ring, right? Firstly, I'm just making the product on next page, the reactant on next page for acid catalyzed reaction, right? This is CH2CH, CH2, CH double bond CH2. Firstly, tell me what will be the carbocation. If you talk about acid catalyzed hydration, in that case you will have the formation of carbocation. So what kind of carbocation will be formed? Where carbocation is more stable. So in this case carbocation is less stable. In this case carbocation will be more stable, right? In this case carbocation will be more stable, right? So I'll have this kind of carbocation formation. The carbocation that I will form is, this is my CH2, this is CH positive, and to this I will have CH3, one hydrogen will be added here. This will be my carbocation formation. After this, is any rearrangement possible? If you talk about the rearrangement, this is my 2-degree carbocation, right? But if I shift this carbocation to this place, then I will have something like this. To this benzene ring only, you will have the attachment of, this is CH2, this is positive, right? And this is your CH and this is CH3. One hydrogen will shift to this side, so we will have one hydrogen here, and this hydrogen will shift to this side, right? This hydrogen will shift to this side. Hydride shift will be there. Now tell me, is this more stable or this more stable? Here you have only 2 degree. But this is 2 degree plus rearrangement. This is 2 degree plus rearrangement, or you can say not rearrangement, 2 degree plus resonance. 2 degree plus resonance. Because here the electrons are going to jump here, right? Then these electrons will jump here, and then these electrons will jump here. So eventually it will have resonance also. Yes, both are 2 degree, but there is involvement of resonance as well in this structure. So this is my most stable structure, and to this structure OH will attach, and hence you will have the formation of this product CH, this is OH, then you will have CH2, CH3, right? So I'm writing the product here. The product is here you will have CH, OH, then you will have CH2, CH3. This is the answer for acid catalyzed. Second is when you have oxymercuration, demercuration, OMDM. For oxymercuration, demercuration, what will be the answer? Simply the answer is going to be, for oxymercuration, demercuration, a very simple concept is that in this case, what you will do, you will not just say that, okay ma'am, oxymercuration, demercuration, ma'am, I will directly apply this concept. Which concept you will apply? Here though we can't apply direct concept. Here we will apply Markovnikov rule, right? The rule is Markovnikov rule. Markovnikov rule we will apply here, and hence you will have the formation of, tell me, Markovnikov rule is that to this double bond where the OH negative part will be attached. OH will be attached to less number of hydrogens. That means this will be CH, this is your OH, and this is your CH3. Right? When you talk about hydroboration oxidation, in this case, you will have anti-Markovnikov rule. Anti-Markovnikov rule means negative part to more number of hydrogens. So you will have benzene part here, and this is CH2, this is CH2, then this is carbon. This double bond will break, and your negative part is attached to more number of hydrogen, means this part. Right, so it will be CH, CH2, OH, and here you will have hydrogen, right? So these are the 3 different products where we are forming, from alkenes, we are forming this alcohol, but the products are different because the mechanisms are different. right? If you ask me, mechanisms are important, yes, they are important, but why they are important? So that if you're like, ma'am, I remember mechanism, like word to word, learn, line to line, I remember the mechanism. Anyone can cram the mechanism, but the difficult part is to apply that mechanism in your reactions. So this is the application of mechanisms, right? Here you should know carbocation and then rearrangement. Here you should know there is anti-Markovnikov rule, Markovnikov rule, and here you should know that there is anti-Markovnikov rule. Which rule we are applying where, right? That is important for you when you are solving the questions, right? You pick out questions, they will not be like write down the mechanism. It's not a subjective thing, right? Okay, understood? Yes, students. So now that was about your from alkenes. Now let us do some other things, some other questions directly that they can ask you. Now this is with the cold action. From alkenes only I am telling you. From alkenes only how you can make alcohols. First is by cold dilute alkaline KMNO4, right? Now this is also called Bayer's test. This is also called syn dihydroxylation. Why syn dihydroxylation? Because it is syn addition. What is syn addition, ma'am? When you have a double bond and this is your double bond, OH is attacking from both sides, like from the same side, right? OH is attacking from the same side. For example, this is your double bond, one OH is attacking from this side, one OH is attacking from this side. That is called anti-addition, right? So here we will do the syn addition, right? So what are the reagents for syn addition? Very, very important concept, right? This is your JEE PYQ, right? That's why I'm telling you this is a very, very important question, direct question. That is when you have dilute alkaline KMNO4 at 273 Kelvin. Here you will have syn addition. That means the OH group is going to be on same side, right? They are on the same side. This is your syn addition, right? This is your syn addition, right? Also, if you have used OSO4, right? Osmium oxide you have used, also then you will have the syn addition. Both of them will have a syn addition, right? So for syn addition, either you can use dilute alkaline KMNO4 or you can use OSO4 in presence of NaHSO3, right? They both will show the same product, that is your syn addition product. But if you want to know about anti-addition your peroxides. If you want to use peroxy acids. Now what are these peroxy acids, ma'am? Peroxy acids can be peracetic acid. Like you have acetic acid, in this you will add one more oxygen here. This is your acetic acid, right? COOH. You will add one oxygen, that will become peracetic acid, right? Trifluoroperacetic acid. You will have 3-fluoroacetic acid. This is your acetic acid. To this acetic acid, just add one oxygen, that will become trifluoroacetic acid, right? Trifluoroperacetic acid, right? Then what is very, very important? MCPBA. What is metachloroperoxybenzoic acid? In peroxy, that means in COH you will add one oxygen, peroxy bond you need here, right? This is metachloro. On meta position you will have chloro. Now if they give you any of these reagents, that means you are going to add OH on the double bond, but that is going to be anti-addition, right? This is going to be anti-addition, not syn addition. This is going to be your anti-addition. Ma'am, what do you mean by anti-addition? Anti-addition means one OH is going to attack from this side, other OH is going to attack from this side, right? So here one OH is over here, other OH is here, right? So opposite sides they are going to attack. That is going to be your anti-addition, right? That is going to be your anti-addition. Yes, Suhara, that is going to be enough, right? Okay. Now, let's do some questions based on this, right? Let us do some 2-3 questions based on this. I'll your PYQ only it is, right? Now, what is the answer for this one? Here they have given you 2 reactions. They are asking you what is X and what is Y, right? So, firstly, they have used KMNO4 in presence of water and OH. Basically, this is the Beer's test, right? This is the Beer's test. 2OH will be attached here, right? But this is syn addition. This is syn addition. If you talk about meta-chloro perbenzoic acid, right? So in that case, it is your anti-addition, right? So that means this double bond will break, but in this case, you will have syn product. Now both are on the same plane only. These are the syn product. But if we talk about anti-product, one will be solid, other will be dash. One will be solid, other will be dash. So that is your anti-product. This is your anti-product. This is your syn product. This is your syn product. So that means X is this one and Y is this one. So that means both B and C are true. Both B and C are true. So answer will be D is your correct answer, where both of them are true here. Right? Both of them are true here. So this is what we are going to see. That where you have syn addition, where you have anti-addition, right? So now in NEET, they don't ask these kind of questions, right? But in JEE, they ask these kind of questions. You should know where there is syn addition, where there is anti-addition. These kind of questions are frequently asked, right? Okay. So D will become your correct answer, right? Now, next is, firstly we talked about from alkenes, we talked about different things here. Now we are going to talk about from carbonyl. That is the second part. From carbonyls, what we are going to do. From carbonyls, right? Carbonyls means you will have C double bond OH. You will have C double bond O, here R and here also R. So either we are talking about aldehyde or we are talking about alkene. So we are going to make alcohols from that. So see students, one very important thing for this is that you should know what exactly is happening here. Right, then we will talk about the reagents, right? Then we will talk about the reagents here, right? So, why 3 boxes here? Directly I am telling you what we are going to see here. Okay? Different reagents we will use here, right? So, you should know a basic chart here. So, these are the type of alcohols. This is what is the action with mild oxidizing agent. This is the action with strong not oxidizing, here so we will reduce, no, yes, here so we will do the reduction, right? So reduction, no, let's not see the reduction, that we will see in the properties of alcohol, yeah. Oxidation we will see in the properties of alcohol, this is the reduction only. Why reduction? Because always remember, OH when it is oxidized, it will give aldehyde or ketone. It depending upon what kind of alcohol it is. Then after further oxidation, it will give carboxylic acid, right? Now, this is the oxidation part. This is the oxidation part. When you are oxidizing it, when you are doing the oxidation, then it is going to give you this chain. But when you are reducing it back, carboxylic acid will get reduced to aldehyde ketone. Aldehyde ketone will get reduced to alcohol. Now this depends on what kind of reducing agent you are using, right? What kind of, there are 2 main reducing agents that you have, that is lithium aluminium hydride and sodium boro, NaBH4, right? So LiAlH4 and NaBH4, these are the 2 main reagents that we will be talking about. So first is that they are saying that when you have aldehyde or you have ketone, so what will happen? You will add hydrogen either by any reducing agent or by catalytic hydrogenation, you will do that, right? So now here also reagents are important for you, because lithium aluminium hydride will do a different work as compared to sodium borohydride. They will do a different work. So one will maybe reduce double bond as well, other will not reduce double bond. So these are the different things that they will behave, right? So when you talk about the general reaction, what will happen? Here we will have the addition of H, here you will have the addition of H. So you will have the formation of alcohol, right? This will form a 1 degree alcohol. If you talk about ketone, here you will have OH here, you will have H here, and hence you will, this OH is connected to that carbon which is further connected to 2 more carbons. So this will have the formation of 2 degree alcohol. So always aldehyde forms 1 degree, ketone form 2 degree alcohols, right? Right? Okay. Now, next is, ma'am, what are these different reagents? So, first reagent is when you have catalytic hydrogenation. That means you have H2 and this is a catalyst that you are using here. So, simply what will happen? It will reduce everything. Catalyst used for reduction, finally divided nickel, platinum, palladium, anything you can use, they will reduce everything, right? They will also reduce double bond. They will also reduce triple bond, right? Everything they will reduce. For example, you have something like this, double bond, this is CHO. So the answer will be, it will reduce everything. This also will be reduced, then this also will be reduced. This CHO will be converted to OH, and CH2OH, and this will be converted to alkane, right? That is, this double bond will get reduced to a single bond, right? So they are not selective in nature. But if we want to have a selective reduction, then we will use some specific reagents, right? Then we will use some specific reagents. So when you want to have a specific reduction, then what you will do? First thing is lithium aluminium hydride, right? For lithium aluminium hydride, they are saying if you have aldehyde, it will convert it to 1 degree. If you have ketone, it will convert it to 2 degree. If you have an acid, it will convert it to 1 degree. Again, acid is also, because acid is a terminal thing. Terminal. Aldehyde is a terminal group. Acid is a terminal group. Acid anhydride is a terminal group. Then acid chloride is a terminal group. Then ester is a terminal group. All these terminal groups will be converted to 1 degree alcohol. 1 degree alcohol, right? Alkene, alkyne, benzene rings are not reduced by, very important line, are not reduced by LiAlH4 but in ether. If they are saying you have lithium aluminium hydride in ether, then they will say, right, it will not be reduced. But it is reported that double bond can be reduced by LiAlH4 in a cinnamic system, right? So for example, they are saying that you have LiAlH4 in presence of TH4 and this is your H2. Now what will happen? You will have CHO, you will have a double bond here, right? So in this case, this aldehyde is reduced and this double bond is also reduced, right? This double bond is also reduced. Now it is not behaving as a selective reagent, right? It will only behave selectively in some parts. In some it will not behave selectively, right? Okay. Next is NaBH4. Now NaBH4 is very interesting, right? Why it is very interesting? Because of this thing. NaBH4 will not reduce carboxylic acid or ester. It will not reduce. It can reduce ketone, it can reduce aldehyde, it can even reduce acid chloride, but it will not reduce carboxylic acid and ester. It will not be reduced, okay? It will not be reduced. Students, everybody tell me, is this thing clear or not? Now first thing was we talked about LiAlH4. Now about LiAlH4, it is selective or it is non-selective, we have to see. So when we say it is selective, it will think that I don't want to reduce double bond, I don't want to reduce triple bond, I don't want to reduce any benzene ring, any double bond of benzene ring. But that is only possible when it has LiAlH4 in presence of ether. If you have ether as a reagent, then this, if I say instead of this THF, I had ether, then answer would be, this double bond would be intact. Right, this double bond would stay intact. But now as I have the presence of THF, then in this case it will also reduce this double bond. That is a very important thing, right? Okay, that's a very important thing. Now, when you talk about NaBH4, right, this is so simple, 1 degree ketone to 2 degree, acid chlorides to 3 degree, to 1 degree. But what is important, that LiAlH4 is going to reduce all these things to alcohol, right? Even catalytic hydrogen is going to reduce everything. But NaBH4 is even more selective. Forget about alkynes, alkenes. It does not even reduce if you have carboxylic acid. If you have ester group, it will not reduce it. NaBH4 will not reduce it. But LiAlH4 will definitely reduce it. So NaBH4 selectively reduces carbonyl of aldehyde, ketone and acid chloride without affecting the double bond. NaBH4 is not going to affect the double bond, that is the for sure. Now understood, three things we talked about. One is catalytic hydrogenation, other is LiAlH4, third is NaBH4. Three things. It will reduce catalytic hydrogen, will not care about anything. It will be like, okay, double bond, I will reduce you. Okay, benzene ring, I will reduce you. CHO, I will reduce. Ketone, I will reduce everything, whatever comes to me, even double bond, single bond, even double bond, triple bond, benzene ring. I will not be able to be like, okay, let them stay as it is. No, right? I am not sympathetic. I am not empathetic toward them, right? Now you have LiAlH4. It's like, okay, right? It will be like, I will reduce all these big groups, but I will spare double bond, triple bond, benzene ring. But if you give me THF, I will reduce that as well, right? NaBH4 is very strict. It's like, I don't want to reduce carboxylic acid or ester. I don't want to reduce any double bond, triple bond, nothing I want to reduce, right? So on these basis, they will ask you the questions, right? Okay, on these basis, they will ask you the questions. Now let us see some of the questions, like, for example, you have NaBH4. Now, see, in this case, if you have NaBH4, we know that CHO bond, it will reduce to OH, but it will not reduce this double bond because it is very selective in nature. It is very like, I am very selective in nature. I don't want to reduce this double bond, right? What if you had LiAlH4 in presence of ether? What if you had LiAlH4 in presence of THF? Now see, if you talk about LiAlH4 in presence of ether, then what will happen? This is your CH3, this is CH, this double bond will stay as it is, because in ether it has no effect on that, right? It has no effect on the double bond, but it affects the CHO group, so it will be CH2OH. But when I talk about LiAlH4 in presence of THF, now it will think that I will reduce this double bond because now I have THF, right? So it will reduce this double bond, so it will be CH, this will be CH2, this will be CH2, and this is your CH2OH. This thing will be formed here, right? This thing will be formed here. Shall I give you one more question based on this? Shall I give you one more question? For example, you have something like this. You have C double bond. This is CHO, right? Okay. Here you have COOH, right? Now you have these things. This is H and this is your H, right? This is H2. Now I am giving you different reagents. First thing is I am giving you NaBH4. Second is I am giving you nickel and hydrogen. Third I am giving you is LiAlH4 in presence of ether. Then I am giving you LiAlH4 in presence of THF. Now there will be different products in all these cases, right? Different products in all these cases. What will be the different products here, right? What will be the different products? Okay, now let us see. Let's try. Okay. First is NaBH4. NaBH4 is not going to do anything to this double bond and not going to do anything to this carboxylic acid. It will stay as it is, right? So answer will be, this is your C double bond, this is CH, this is COOH, right? It will stay as it is. This is CH, but it will definitely reduce this CHO to CH2OH. That will be the product, right? What about the second one? What about the second one? In this case, what will, I don't think so it will be possible for me to write it like this, right? So what I'll do, I'll just mark it A, B, C, D. Okay, this is my A. For example, this is my A, this is my B, this is C, this is D. Right, so A option is this one. B is what? B is what? B will be, when I'll say nickel and hydrogenation. So this is catalytic. It will not spare anything. Well, you're a very rude person. So it will reduce everything. This COH is reduced to CH2OH, right? This CH is reduced to CH2CH2. And this CHO is reduced to CH2OH. So this thing will be formed in case of nickel. Like you have catalytic hydrogenation. So what is C? What is C? In C case, what you will have? You have lithium aluminium hydride. Lithium aluminium hydride, okay ma'am. Now tell me, in case of ether. Ether is like, I don't want to do anything to this double bond. But I can reduce this COH. Because lithium aluminium hydride, it will definitely reduce all the, whether it's carboxylic acid, it's ester, it will reduce it, right? So it will be like, this is CH2OH, this is the reduction of COH, now this is CH2, no, it will not be reduced because this is in presence of ether. So it is not be reduced, double bond, and here it will be CH2, this is CH2OH, this is CH2OH, right? Very good. Now, in the last case, that is your D part, it is going to reduce definitely this COH also, this CHO also. But this is in case of THF, that is why it is also reduced this C double bond, right? So answer will be same as this one, that is CH2. B and D are same only, right? B and D are same only. So answer will be CH2OH, this is CH2, single bond CH2, CH2, CH2OH. Understood how to apply the concepts? Everybody in the chat box, are you able to understand how to apply these concepts? Just understanding that ketone will give rise to alcohol? No, you also need to understand the reagents. The knowledge for organic chemistry is the knowledge of reagents. Which reagent is going to behave in what way and how they can just twist the product, right? So now you can see in that product of B and D are same, but rest of these are different, right? So depending upon the property of reagents, the product will vary, right? Okay, everybody. Okay, everybody. So this is about that only. This is LiAlH4. It's a strong unselective reducing agent. It will reduce aldehyde ketones. We have moved one step ahead also, right? Then it is a very expensive reagent. Now it is important that LiAlH4 is a very expensive reagent, right? That is why instead of directly converting COH to CH2OH, what we do, we will first do the esterification. We will convert this into ester, and after this we will do the hydrogenation, catalytic hydrogenation, and then this will be reduced to RCH2OH, right? Next is from alkyl halides. If you talk about alkyl halides, right? So now what you have to do here, remember, when you have KOH alcoholic, in that case what happens? Anybody in the chat box? When you have KOH alcoholic KOH, in that case, what it will do? It will cause dehydrohalogenation. One hydrogen will be eliminated, one halogen will be eliminated, and you will have the formation of alkene, right? In this case, you will have the formation of alkene. But when we talk about KOH aqueous, that is a different thing. Don't get confused here, right? You have two things. One is alcoholic KOH, other is aqueous KOH. When you have aqueous KOH, simply it will replace this halogen group to OH group. Simple, right? But when you have alcoholic KOH, then you will have the formation of alkenes. That we will do, right? That we will do in the properties, right? We will do that. Don't worry, right? It is in haloalkanes and haloarenes, right? Okay. Yes. Now, yes, this is a substitution reaction, so directly this will happen. Now, if you talk about from Grignard's reagent also, this is very, very, very important. They will ask you, the questions that they ask in JEE is, they will ask you what, for example, they have given you a product, right? They will ask you what are the predicted reactants for this. These kind of questions they ask you, right? So I'll tell you, firstly we will see how this is done. For example, I am talking about HCHO. Just see how I am doing this. HCHO, and this is RMGX. Now, this is an organometallic compound. What is organometallic compound? Where alkyl chain of organic chemistry is attached to a metal. So there are different organometallic compounds like Grignard reagent, this one, or like R2CuLi, this is your Gilman's reagent. This you must have seen in organic chemistry as well, right? It's a different branch of chemistry. Organometallic compounds is a specific branch of chemistry, right? So it is like very useful in today's time, right? Our science is like, trying to research on organometallic compounds more and more, because they are very useful, right? So yes, now let us talk about this Grignard reagent, this organometallic compound, right? This carbon of this alkyl chain. Now we know that metal is very electropositive, right? Because metal is usually carbon will have a positive charge, because carbon in front of oxygen is very okay, I am very electropositive, so this is having positive, this is having negative. But when we talk about that carbon is in front of a metal, carbon is electronegative, because metal is very highly positive, right? So that is why here it will be negative, here it will be positive, right? So here that is why the answer is going to be, this will have partially positive charge, this will have partially negative charge. In this case, we know that in carbonyl compounds, carbon is definitely electropositive as compared to oxygen, right? So firstly, you need to understand the electropositive and electronegative character here, right? Okay. Yes. No, I am not coming for KCT launch, but I have told sir my syllabus, that how I am going to proceed with the syllabus of KCT. So don't worry about that. You can just see the launch. What sir is going to talk about chemistry is basically what I told him, that okay, these are the chapters that I am going to complete. So he will convey the message to you, right? Don't worry about that, right? Okay, yes. Now, this is your positive, this is negative. Now, always in chemistry, positive, negative, negative, positive. This will happen in chemistry, positive, negative, negative, positive, right? So basically, ma'am, what is this positive, negative, negative, positive, ma'am? What you are going to talk about positive, negative, negative, positive? Positive, negative, negative, positive means here we know that what will happen to more electronegative, because here it is having a pi bond. Pi bond is a weak bond. Pi electrons have sideways overlapping. That is a weak bond. That is why electrons are going to jump here. It will have CO negative and this will be positive. It will be H. It will be H. It can be anything. It can be alkyl. I am talking about, let's take R here. Okay, let's take anything here. Anything you can take here. Let's take R here. If you are taking R also, that will be the same answer only. It's not like the answer will change, right? Now, take R dash, because R is already here, no? So, yes. So, it will be R here, right? Now, I know that through this negative, this positive, through this negative, this positive part will attach, right? What is the positive part? Wait a minute. I have drawn the opposite. Yes. It is electropositive. This is electronegative, right? Okay. So, this is the positive part. This positive part is going to attach here. That is MgX, right? And this negative part is going to attach here. That is R. Then after the hydrolysis, this MgX is going to replace by this hydrogen. This is the process of any reaction with Grignard's reagent. Any reaction which has pi bonds, whether you talk about RMgX with CO2, it will proceed with the same thing. RMgX with HCN, it will proceed with the same thing, right? So, same kind of things throughout chemistry, whether it's aldehyde ketones also, we will see reactions of Grignard reagents to form different products, right? the mechanism is going to be same only, right? So here what we are going to do, it will be R dash CO negative, this is your positive, and this is H. And again what will happen, this O negative, it will attach, so it will be OMgX, and this is your hydrogen. And to this positive, this R negative is going to attach. Then after hydrolysis, you will have the formation of this O. You will have the formation of this OH, right? I was so much in hurry. Yeah, so this will be OMgX. So after this, what you will have the formation of, this is carbon, this OH, and this is H, and this is R, right? Whatever you say, whether it's methanol, it's aldehyde, it's ketone, right? How it will change, everything is going to be same, right? If I talk about methanol, if you're like, ma'am, I want to talk about methanol, replace this R dash with hydrogen. Replace this R dash with hydrogen, right? I have replaced this R dash with hydrogen. This is my methanol, right? It will be as it is, it will be as it is, it will be as it is. Now what I had? I have the preparation of 1 degree alcohol, right? With, except for methanol, other aldehydes, you will have the formation of 2 degree alcohol. Now ma'am, what about ketone, ma'am? What about ketone, right? What about ketone? Do the same thing, Just replace this R dash, not R dash, just replace this hydrogen with one more alkyl chain. With one more alkyl chain, replace this hydrogen. So I am going to replace this hydrogen with one more alkyl chain, R dash, this is R dash, and R dash, right? And now what you have? Everybody in the chat box, what is this? This is 3 degree alcohol. Ma'am, right? So based on Grignard reagent, right, depending upon whether it's methanol or any other aldehyde or a ketone, what will be the product, 1 degree, 2 degree or 3 degree, right? That you will answer, right? Now, the question that they can ask you, this is for 2 degree, this is for 3 degree, right? Now, the question that they will ask you is something like this. They will ask you, which of the following combination is suitable for preparation of 3-methyl-2-butanol? 3-methyl-2-butanol. Firstly, you have to make the answer. What they are asking you, 3-methyl-2-butanol, 1, 2, 3, 4. 2-butanol means 2OH. 3-methyl means, if you talk about 3-methyl CH3 here, I have to complete the full hydrogens here. So it will be H, it will be H here, it will be H3 here, right? Now, I know that what they are forming here. They are forming which kind of 1 degree, 2 degree, 3 degree. This OH is attached to that carbon, which is further attached to only 2 carbons. So this is basically 2 degree alcohol. This is basically 2 degree alcohol. For 2 degree alcohol, I will need one aldehyde except for methanol, plus I will need RMgX. Now I need to understand what should be my Grignard reagent and what should be my alcohol. So which alcohol is a 2 degree? Which aldehyde is which is the aldehyde here, right? So here, this is your ketone, not possible. This is my acetaldehyde. What is acetaldehyde? That is CH3CHO. Plus, what I need to have? You have CH3CHO. Then, what if my Grignard reagent is coming from this side? What if my isopropyl, hai na? So what if my Grignard reagent is coming from this side? This is my RMgX part, and this is my which part? Aldehydic part. Then I can form this. Ma'am, how? Let us see. Now this is basically, if I want to see that what will be the answer here, this is C, this is C, this is C. If I have MgX here, right, then how I can have this desired product. Let us see that in the next page. CH3, C double bond O, H plus, this is CH3, CH3, MgX, okay. This is CH3, this is CH3, this is H, this is MgX, right? Now this is my negative part, this is my positive part, this is my negative part. This is, the electrons will jump on this side and hence you will have the formation of CH3, C, O negative, this is positive, this is H. To this positive, this whole negative part will attach. That means this carbon attached with 2 CH3. Attached with 2 CH3 will attack here, right, and 1 hydrogen here. And to this negative part, MgX part will attach. Then after the hydrolysis, this MgX will be converted to H. And hence this is going to be your final product, right? Isn't it the same thing? Isn't it 1, 2, if you talk about 1, 2, 3, 4, if you talk about 1, 2, 3, 4, isn't it 3-methyl butanol, right? Yes, students? Yes. Those structures, pyroglyphs, triol, right, benzene 1, 3. Sathi, I will verify that. According to me, that is right, but I will verify that. Okay. Now, this is your 3-methyl butanol, right? So, that becomes your 3-methyl butanol. That is C is the correct answer, right? Now, let us see the next part here. Can you see this question? In the following reaction, this is the reaction. They are saying that in the following reactions, this is the reactant. They have given you 2 reagents here, right? First is NaBH4, other is LiAlH4. Now, when you talk about NaBH4, it is only going to attack on the carbonyl group of aldehyde ketones or acid halide, right? That is acid chloride or something. But here we have an ester group. This is the ester group. And this is ketonic group. This is ketonic group. This is the ester group. And this is the ketonic group. This is the ketonic group. Now, if you talk about the ester group here, in ester group what will happen? In ester group, this full group is converted only in case of LiAlH4, right? Not in case of NaBH4. So, in case of NaBH4, this will stay intact. This will stay. This in both cases not possible. In first case, that is your C. C is what? In C it will stay as it is, right? So, in C, only in this case it is staying as it is. This ester group is as it is, but ketonic group is getting reduced to OH, right? But if you talk about this thing here, if you talk about LiAlH4, that is your B. That is your B part, right? In this part, what you have seen, that this ester group is also reduced. How it will get reduced? How the ester group is going to reduce? This will reduce to OH and this will also reduce to OH. So, this will be carbon and here 1 bond and this is OH. Carbon 1 bond and then OH. This is directly reduced to OH. Directly to OH. Right? Okay. This is that bond, this bond and then this bond is this bond. Right? So, it is 2 bonds and then OH. So, that means this is your B part. Right? That means this is your B part. So, answer is A will become the correct answer. Right? So, these kind of questions they can give you. Right? Okay? Okay, students, these kind of questions they will give you. Now, let us see the properties of alcohols. Right? Everybody ready for properties of alcohol? Hanji. Properties of alcohol. Very, very important. A lot of things we are going to do here. First is physical properties. Just go through them once. Alcohols are colorless liquid with specific smell, right? They are soluble. The syrups that we use when we have cold, cough, the syrups that we use also have alcohol, some percentage of alcohol in it, right? So in that also you have a specific smell of alcohol, right? Okay, so alcohol are colorless liquid specific smells. They are soluble in water. Why they are soluble in water? Because water is this, right? Because of two lone pairs on it. And if you talk about any alcohol, this is ROH. This will form a hydrogen bonding. And again, one more molecule of this will form one more hydrogen bonding, right? So basically, alcohol is going to form hydrogen bonding with the water molecule. That is why they are soluble, because of the hydrogen bonding. These are partially soluble in organic solvents like benzene, right? They are partially soluble, right? Because with them they don't have as such hydrogen bonding, right? So they are liquid in nature up to 12 carbon, they are liquid in nature, right? Next is melting point and boiling point, always. Melting point, if you talk about melting point and boiling point, right? Melting point is usually based on the symmetry. It is more of symmetry based thing. Okay, so it is mostly based on the symmetry. If there is more symmetry, then melting point will be high. If there is less symmetry, then melting point is going to be low. But if you talk about the boiling point, in that case, boiling point is very different as compared to melting point. In case of boiling point, what will happen? More is the molecular mass. As the number of carbon increases, the boiling point will increase, right? But as the branching increases, for example, we have N, then we have iso, then you have neo, then which will have highest boiling point? This has more branching, so it has lowest boiling point, so this will be the answer. This has less branching, so it will have more boiling point, right? So that is going to be the answer. Boiling point of alcohols are higher than equivalent ethers. Can you tell me why boiling point of alcohols are higher than ethers? Because in ethers, for example, I take this ether, CH3OCH3. This is my oxygen. So in this case, what will happen? The hydrogen that is attached here, exactly what will happen, no? In case of alcohols, the molecules itself will have hydrogen bonding. For example, you have one molecule of alcohol, that is ROH. You have other molecules of alcohol, that is ROH. Now they will show hydrogen bonding with each other, right? But when I talk about this kind of thing, here, this hydrogen is attached to an electronegative element. That is why this hydrogen was showing hydrogen bonding with this oxygen, right? Wait a minute, let me write that again. For example, you have CH3, this is O, this is H, right? This is CH3, this is O, and this is H. Now I am saying that there is hydrogen bond between these two things. Now why this hydrogen is showing hydrogen bonding? Because this hydrogen is directly attached to an electronegative element. That is why it is showing hydrogen bonding. And then that is why, because of this high electropositive charge, it is showing hydrogen bonding with this oxygen. But that is not there in the case of ether. In ether, this hydrogen will not show any hydrogen bonding. All these hydrogens will not show any hydrogen bonding. Reason? Because they are not connected to any electronegative element directly. So the reason for hydrogen bonding is that the element, the hydrogen should be the hydrogen which is showing hydrogen bonding with some other electronegative element. That hydrogen should be connected to an electronegative element. Only then it can show hydrogen bonding. Otherwise, it is not possible. So in this case, there will be only van der Waals forces. It is due to the hydrogen bonding. They are saying it is due to the hydrogen bonding that alcohol have high boiling point as compared to ethers. Yes? Yes. Very good. Yes, ma'am, electronegative difference is low. Very good. Now, next is reactions as an acid. Now alcohol are acidic in nature. Now which will determine the acidity of alcohol? Now always remember when we are, I'm just revising this concept of GOC here, right? Whenever we will talk about the acidity, we will talk about one thing here, that for example you have HA. Now HA is going to give H positive then A negative. H positive then A negative. Now what is a acid? Acid is something which is proton donor. So if it donates proton only, then it will be an acid. Now when it will be a good acid? Now for example, you have 10 pizzas, right? And I'm asking that, can you please give me one pizza? You will be like, yes ma'am, I can give you one pizza. Ma'am, no issues. I have 9 other pizzas with me. So you can say, ma'am, I can easily give you. Why? Because it will be like, ma'am, I am stable after giving you one pizza. I still have 9 pizzas, right? Now, for example, you have just 2 slices and you are very hungry, right? Then I am asking you, thank you, Pranav, thank you. So now, if I am asking you, you have just 2 slices of pizza, right? And I'm asking you, can you please give me 1 slice? Can you please give me 2 slices? You'll be like, ma'am, what you are asking, ma'am? I am very hungry, ma'am. I have only 2 slices of pizza. You are asking me to give you that also. Ma'am, what I will eat, right? That means you are not stable after giving me that pizza slices, right? So that means if after giving H positive, this will become good acid only if this carbon ion is stable. So whenever we are talking about the stability, this is going to be a good acid if this carbon ion is stable, right? Okay, if carbon ion is stable. Now next thing is, ma'am, how we will understand the stability of carbon ion? Always remember, when we are talking about carbocation, just think it as money. And carbon ion, just think it as stress. Right? Just think it as stress. Now, for example, you have electron donating group who is giving you money. You are positive. You have less money. Someone is giving you money. Then you will feel happy. Right? You will feel happy. You will get stable. But if you have electron withdrawing group, in that case, we are talking about money only. We are talking about positive carbocation. You have electron withdrawing group. Someone is taking out this money from you. They are taking out this money from you. I'm like, why they are taking out money from me? Right? I am already very poor. So you will become unstable. You will become unhappy. This is stable. This is stable. This is unstable. This is unstable. Opposite is for carbocation, right? This is like a stress. For example, you are already under stress. Someone is giving you more stress. They are donating you more stress. You will become unhappy. You will be like, I am already under stress. You are talking about this and that to me. You are giving me more stress, right? So you are making me unstable. You are making me very, very unstable. Now, for example, you have electron withdrawing group, right? You are like, okay, I was under stress, but I talked to my best friend. My best friend talked to me for 3-4 hours. Now I am very happy. Why? Because now I am out of the stress, right? They have withdrawn the stress from me. That is why now I am very happy, right? This is called stability. This is called when you are more stable, right? This is why you have more stability, right? Okay, this is when you have more stability, right, students? Okay, everybody in the chat box, tell me. This is the concept that we are going to apply when we will talk about acidity and basicity, right? Specifically acidity, right? Okay, now 1 degree, 2 degree, 3 degree alcohol, which is more acidic, right? So what we will do, we will talk about after losing H positive, it will become a carbon ion. Now which carbon ion is more stable, we will talk about that. After losing H positive, it will become, these 3 carbon ions will be formed. This is negative, this is negative, this is negative. Now tell me, negative means stress. If someone is giving you more stress, you will be like, get out of my life. right? So this is giving stress from one side. Here this is giving stress from two sides. Here this is giving stress from three sides. So which is more stable? Where you have less stress, right? So this is primary is more stable, then secondary, then 3 degree. That is why 1 degree alcohol, it is like I am stable after giving H positive. That is why I will donate H positive, right? 2 degree will be like I am not that stable, so I will think about whether I should give H positive or not. It's like I am not at all stable after giving you H positive, right? So that is the order of acidity. That becomes the order of acidity due to the inductive effect. Very good. What is this donation called? This is called the inductive effect of alkyl groups, right? This is called the inductive effect of alkyl groups. Next is reaction with metals. Now, for example, here we are talking about the reaction of alcohols with metals. So now what will happen? You will have this ROH with the sodium. Now what will happen? You will have the formation of sodium alkoxide, right? Sodium alkoxide, basically because alcohol is very acidic in nature, right? Alcohol have this acidic nature, isn't it? Alcohol has this acidic nature. Sodium behaving as a base here. Sodium is behaving as a base here, right? It is what it is doing. This basically this H positive, right? It is getting donated by this acid, that is your alcohol. It is acidic in nature. It will donate H positive, and here sodium will replace that H positive. It will form a salt. We know that when you have, basically even if you talk about this is a metal, this is having a basic nature. It is a metal. We know that an acid with a metal, what is the reaction? This we have understood in 9th and 10th class. You have learned this reaction, that acid with metal, what it will form? It will form salt plus hydrogen gas, isn't it? Isn't this the same reaction? Acidity of alcohol plus metal, salt and H2 gas, right? Isn't it the same thing? Is this something that we should remember? It's the same thing, because this is acidic in nature. That is why with metal, it is forming a salt, that is RONA plus H2, right? And this RONA is called sodium alkoxide ion, right? Okay, now we will talk about a different element, that is your Al. Now we know that sodium had a valency Na positive. Sodium had a valency 1. But aluminium has which valency? What is the valency of aluminium? 3. That is why 3 alkyl groups. It needs 3 valency. It needs 3 alkyl groups. If it wants to be in anion, if it wants to be in a cationic state, here it is positive, this is negative. Na positive is a stable thing. But Al3 positive is a stable thing here. That is why what you have the formation. Here this is not like, ma'am, I will have the formation, I will replace this with Al. No. Why? Because aluminium is stable in the 3 positive state, right? For 3 positive, because of the cross valency, what it should have, over here it should have 3 opposite things, right? If it is a cation, 3 opposite anions should be there, right? So that is why 3 molecules of anion should be there. That is why we have 3 butoxides, 3 third butoxides ions here, right? So basically this will become thrice, and here Al will be, H will be replaced by Al. That is the answer. Okay, why here you have 3? Because of the valency of aluminium, right? Okay, if you talk about magnesium, it would have been 2. This would have been twice, because magnesium has 2 valency, right? Because magnesium has 2 valency. Now, next is esterification reaction. In esterification reaction, let us see what will happen. Esterification reaction is usually we know about carboxylic acid, but it can also be done by acid chlorides. It can also be done by acid anhydrides, right? It can also be done by acid chloride. It can also be done by acid anhydrides. Anything we can use here, right? So if we talk about carboxylic acid with alcohol in presence of catalyst, will give us ester, right? So basically this RCOH group and this ROH group, they will give us ester, and this is called esterification reaction. Now, if you talk about with acid chloride, it will give us, this is RCO, OH from here, it will again give us not OH, OR from here, it will give us RCOOR and then HCl. But here you should use pyridine, right? Why pyridine is used here? So that it can behave as a, it can actually donate that. Okay, that is why pyridine is used, right? So that this HCl formed here, pyridine is what? This is the pyridine. This is pyridine, right? This is pyridine. This is pyridine. We know it has lone pairs. Now acid is being formed here. We want this acid to eliminate, so that this, according to Lee-Chartlier principle, if you want to make a forward reaction, what you should do? You should start eliminating the product so that it can go in the forward direction. So what I am doing here, this HCl, this is making this whole pH as acidic medium because this is HCl. So that is why I have added pyridine here so that H positive can attack here, so that it can become H, this will be positive and this will be Cl negative. Something like this, right? So that this HCl can interact with this pyridine and the effect of this HCl acid can decrease, right? Okay? Okay? Yes. Now, next is acid anhydride. Third is with acid anhydride. Here what will happen? Wait a minute, let me draw it on the next page. Okay, we don't have space here. Okay, I'm drawing it here only. What is acid anhydride? COO, C double bond O, this is R, this is R, right? So here also what will happen? Basically, this bond is going to attack with OR and hence you will have the formation of ester, right? Hence you will have the formation of ester. Okay, understood? RCOR group is, we are going to form that, right? Okay, so in a simpler way, I have already told you what will happen. RCO bond will attach with OR and hence you will have the formation of this thing, right? Okay, now how this is formed, the mechanism I will tell you. For example, you have H positive, it is in the acidic medium. In acidic medium, you have H positive. Same thing we are going to do in every mechanism. Same thing is happening. Electropositive, electronegative, not electronegative, electron rich. It is going to attack on electron deficient species. So now this is your acidic medium. You have H positive. This is your oxygen. Oxygen will attack on this H positive because this is electron rich. It is going to attack here and hence you will have the formation of OH. Because oxygen is forming 3 bonds, that is why it will be positive. But to oxygen, positive is not stable. O negative is stable, but O positive is not stable. So it will try to fetch some electrons from somewhere. So it will take the electron from this pi bond because pi bond electrons are loosely bound, right? So it will take that electrons here and it will become OH here, right? Then there comes the role of your alcohol, that is R-OH. Now alcohol will say, where should I attack? Where should I attack? Alcohol will be like, I have 2 places to attack. For example, this electrons, they have gone to this side, then this must be a carbocation after this, right? Because if you shift the electrons here, it will have shifted to a carbocation, right? Because here you will have the formation of this kind of thing. This is R, this is C, OH, this is OH and this is your positive. So very, very unstable species. That is why they have not written it in the mechanism. One thing, so you have 2 OH groups on 1 carbon. That is very unstable. Then this is a carbocation. Carbocation is an intermediate. That is unstable. That is why they have not written it here because this species is very, very unstable. Right? Now, because of the electron deficiency here, what will happen? This electron rich group is going to attack on this carbon and this will be O, this is R dash and this is H. These are the new things, right? Now again oxygen has 3 sigma bonds. Now oxygen will be like, I can't carry 3 sigma bonds, I need to eliminate this, I need to have electrons. So it will take these electrons from the hydrogen because hydrogen is not that clever. If you talk about R dash, it is difficult to break the bond of O and R, right? Because oxygen and carbon, they still have less electronegativity difference as compared to OH. So it is easy to break this bond as compared to that bond. That is why instead of taking electrons from here, it is taking electrons from this side. H positive will be eliminated and you will have the formation of RCOH, and this is your OH here and this is your OR here, right? Now this H positive, that is the acidic medium only, right? So H positive is going to attack on this side. Again that is happening. As this is electron deficient, this is electron rich. It is going to attack here. Again oxygen will have a positive charge. Oxygen will be like, I again have a positive charge. It is going to take away the electrons here and eliminate the water, right? Then what will happen? These lone pairs are going to attack here, right? And this H positive is going to shift here, right? Okay, yes. And then you will have the formation of RCO. I am doing this on the first step only. They have done this in second 2 steps, that the first these electrons are going to shift here. Then because oxygen have now 3 bonds, then again it will have a positive. Now what will happen? This H positive will eliminate. The electrons are going to jump here and then you will have the formation of ester, right? Pranav, can you please stop doing this, right? Now this is, you will have the formation of ester here, right? Understood or not? Right? Understood or not? I know you will find that, ma'am, what is this mechanism, ma'am? What all has happened here, right? So do you know what you need to understand? You don't need to cram this full mechanism, ma'am. Do I need to cram this full mechanism? No, you don't need to cram this full mechanism. All you need to understand is what is the oxygen that we have. If you see here, this O is still present. It is still present. It is still present. That means for carboxylic acid, the oxygen is from the, in the ester, we have the formation of RCOOH. Now the question that they can ask you is, this oxygen is from which side? This oxygen is from this side. This oxygen is from carboxylic acid. Carboxylic acid. What about this oxygen? This oxygen, this is OR. This is OR. This is OR. Your OH part has been eliminated. That means this oxygen is from your which part? Alcohol part. This is the reason that I showed you this mechanism, right? You should know which bond we are breaking. That is why here I told you that this whole thing will be eliminated. You will, from whether you are talking about all the things, okay? Whether you talk about carboxylic acid, you talk about carboxylic acid, that is RC double bond OOH. You talk about ester, you talk about halide, acyl halide or acid chloride, or you talk about anhydride, that is C double bond O, C double bond O, R. In all these cases, this will be the part that will be there in the ester. This basically what will happen, this bond will break like this. And hence you will have the part that will take part, that is RC double bond O positive. It's not like a carbocation will be formed, right? That is not the correct answer. I'm not saying a carbocation is formed here. I am saying that this is the part that will take part, that will be your in your ester. This oxygen is not going to be in your ester, right? The oxygen, the other oxygen that is in the ester is not your this part. It is your alcoholic part, right? Yeah, guys, I'm so sorry about this. Yes. Okay, relax. Now we will see that if he speaks again, then I'll have to do something, right? Okay, ma'am, break please. Okay, so I'll give you break after one more reaction. Okay, after one more reaction, I will give you break, right? After Lucas test, I will give you break, right? After Lucas test, I will give you break. Now, what is Lucas test? That is to distinguish something, right? So, 1 degree, 2 degree, 3 degree alcohol we distinguish from Lucas test. What are Lucas reagent? That is ZnCl2 and HCl. That is my Lucas reagent. Anhydrous ZnCl2 and HCl. That is my Lucas reagent. Now, if you talk about 1 degree alcohol, 2 degree alcohol and 3 degree, basically this forms a turbidity. Turbidity means cloudiness, right? Like if you put water in a glass and you put some powder in it, it will form some cloudiness, right? That is the turbidity. If you talk about 3 degree, it will react immediately and it will give us turbidity. Immediately turbidity will be formed. Okay? If you talk about 2 degree, turbidity will be formed after some time, right? Turbidity will be formed after some time. 3 degrees, immediately the turbidity is formed. 2 degrees, after 5 minutes. If after 5 minutes the turbidity is formed, you will say it is a 2 degree alcohol. If you say that the turbidity is formed after how much time? Ma'am, on heating, it is taking hours and hours. On heating, it is forming the turbidity. Then it is a 1 degree alcohol. So this is used. Ma'am, I wrote the mechanism as elimination but got it wrong. Oops. Yeah. I know mechanism part for MCQ. See, I'll tell you where the mechanism is used. So I always tell my students that you don't need to cram this full mechanism. Right? They are not going to ask you this full mechanism. You should do this, right? You should try to understand this, but in the end, what is important for you? The main highlighting points of the mechanisms. Like this oxygen is from carboxylic acid, this oxygen is from alcohol. These kind of things are important, right? Okay. Lakshmi, why I am on JEE channel then? Right? Because you guys were asking for JEE, right? So that's why I'm on this channel, because NEET and JEE are two different things, right? Okay, NEET and JEE are two different things. In NEET, still they don't ask you these kind of questions that I have covered here, right? In JEE, they ask you these kind of questions, right? Okay. JEE means questions can be repeated in NEET, but NEET questions will not be repeated in JEE means, right? Okay, so that's why I'm on this channel. Otherwise, so there would have been just one channel of NEET and JEE, right? Okay? Yes. Now, yes, Pita, that is sufficient. Yes, that is sufficient for your means. Yes. But do PYQs. Yes. Right? Now, let us see 1 degree alcohol. This is 3 degree alcohol. This is 2 degree alcohol. This is 1 degree alcohol. Right? 3 degree alcohol, turbidity appears quickly. 2 degree, turbidity appears within 5 to 10 minutes. Here, turbidity appears on heating. Lucas test is important, but I think it's very simple, right? So, they will ask you these simple kind of questions, right? Okay, so you can just go through this once. Now, next are the substitution reactions that we will do after the break, right? We will do after the break. Now, break time. Now, break time. So, I'll take break of 10 minutes or 15 minutes. How much break you want? 10 minutes or 15 minutes? How much break you need? How much break you want? Lakshmi, I have already answered you. Yes. Narashima, okay. Yes. Okay, how much break? 15 minutes? So, in 15 minutes, we will resume the class. Okay. What is the time now? The time is 9:36. So, 40, 50, 7:50, sorry, 9:46, I am saying 7:36. So, I will see you at 7:50. Right. 7:50 p.m. you guys can have your dinner. Even I will have my dinner. After that, we will talk further. We will deep dive into this chapter more. Okay? Yes? Okay. Okay then. Chalo. Yes, I am not going to give break after this, so you can have your dinner. Otherwise, you will say, ma'am, I didn't have my dinner. Right? Even I'll have my dinner. Okay? Yes. Okay, then see you at 7:50 p.m. sharp. I'll be here. Okay? Yes. Okay, yes, students, am I audible? Students, am I audible? Everybody in the chat box. Yes, Tamiz, Dinesh, Herburain, Prathmesh, Vishnu, Mohit. Everybody in the chat box, am I audible? Am I visible? Shall we restart the session? Shall we resume the session again? Yes, okay. Chal. Now, next thing is substitution reaction. So now what happens in a substitution reaction? Okay. So this is a reaction with halogen acid. First reaction is with halogen acid. If you react this with halogen acid, then this OH will be replaced by this X, right? Halogen acid can be HCl, HBr, HF, HI. If you talk about the reactivity of all these things, we know that the bond between hydrogen and iodine is a very large, big bond, right? It has a distance, right? So it is easy to break this bond because of the large size of iodine. So that is why HI is having maximum reactivity. Then you have HBr, then you have HCl. HF is very explosive in nature, so it will not react, right? So hence this is the answer. Next is, what is the mechanism? Primary alcohol react by SN2 mechanism, while very important, this is your PYQ. This is your PYQ. Secondary and tertiary alcohol react by SN1 reaction, right? Primary alcohol will react by, when you have primary alcohol, that will react by SN2. SN2 means it will have SN2 means one step, it will have transition state. SN1 means it will have the formation of carbocation. So because 3 degree carbocation, then 2 degree, this is 1 degree. Because 1 degree carbocation is not stable, so it will not prefer to be a carbocation and then form the halide. Rather, it will go through a transition state to form the corresponding halide. Right, so with 1 degree, it is SN1, SN2, sorry, right, with 3 degree and 2 degree, it is SN1, right. Then reactivity order is HI, then HBr, then you have HCl. Then what is the reactivity of alcohol? That is tertiary, then secondary, then primary. This is towards SN2, this is towards SN1 mechanism, right. Next is reaction with halogen acids. This is the mechanism we are talking about. Firstly, what will happen? Halogen acid is going to give you proton. Then this proton is going to attack on the electron-rich oxygen of alcohol. Then you will have the formation of OH2. Now what will happen? Because this oxygen is something like this. This is H, this is H, this is carbon, this is positive. So it will donate the electrons here, right? And what will happen? It will donate, not these electrons, actually it will donate this electron here, right? It will donate this electron here and it will liberate water from here, and hence you will have the formation of carbocation. But now it depends which mechanism you are using. Because this is a 1 degree alcohol. This is a 1 degree alcohol. As I told you, 1 degree alcohol will not form any carbocation, that will go through SN2 mechanism, that is your transition state mechanism, right? So for 1 degree alcohol, what will happen? This is your compound, that is protonated 1 degree alcohol. This is not I, this is 1 degree alcohol. This alcohol, what is transition state? What is transition state? Basically, your nucleophile is going to attack from this side and this is going to go to this side, right? It is going to liberate from this side, right? So in between there will be formation of a transition state where this X negative is attacking on this carbon and this OHO, this is breaking the bond between these two carbon and oxygen. So here you are breaking the bond and here you are making the bond. So after that what will happen? This bond will break and hence you will have the formation of RCH2X, and this is the formation of your halide, alkyl halide with SN1 mechanism, right? SN2 mechanism, right? This is one step here. So this will be SN2 mechanism, right? Okay, yes. Now what about SN1? What about SN1? Till here everything is same. You have protonated alcohol. But after, if you want to have carbocation formation, so what will happen? The lone pair, the bond between oxygen and carbon, the electrons will jump to this side. You will have the elimination of water. You will have the formation of a carbocation. And after this formation of carbocation, you will have the addition of X negative, that is your nucleophile on it. Basically two mechanism, SN1, SN2, both ways we have discussed, right? What you have to remember this thing. 1 degree it will show by transition state, but 2 degree and 3 degree it will form carbocation, that is by SN1 mechanism, right? Okay. Now next is reaction with PCl3, PCl5, SOCl3, all these reactions, this OH will be replaced by this Cl, right? These reactions we have already done in haloalkanes, halorines, right? Then next one is, here we have already done these reactions. If you want to see the mechanism, this lone pairs will attack here, right? Then the electrons will jump and this PCl3, PCl2 is going to attack here. Then after, the second step is going to be, this Cl negative is going to attack on this, and OP, that's basically PCl2O, that is going to liberate from this end, and hence you will have the formation of HOPCl2 here, and hence this will be your RX, right? Now next is your oxidation of alcohol. Now oxidation of alcohol is again a very, very important thing, right? As I told you, oxidation of alcohol, you just need to understand this chart, okay? If you understood this chart, things will be very, very easy for you, right? Things will be very, very simple and easy for you. What is this chart? First you have to write what is the alcohol that you are using. Then with mild reagent, with mild oxidizing agent, what is the answer? Then with strong oxidizing agent. Then with strong oxidizing agent, what is the answer? Right? With mild oxidizing agent and with strong oxidizing agent, what is the answer? If you talk about alcohol, if you talk about 1 degree alcohol like this, CH3, CH2OH. In this case, it will firstly be converted into aldehyde, that is CH3, CH2, not CH2, this will be converted into aldehyde, it will be oxidizing agent, right? So here it will be C double bond O, this is H, aldehyde. Again, if you oxidize this, that means by strong oxidizing agent, this will be converted to carboxylic acid, right? If you talk about 2 degree alcohol, that is, you have CH, this is OH, this is CH3, CH3. Now, here this will be converted to ketone first, right? This will be converted to ketone first, C double bond O, this is CH3, this is CH3, right? With further, nothing can happen. So, with strong and weak, it will give the same answer, that is ketone, right? If you talk about the third thing, okay, just give me a minute, Mr. Pranav. Okay, now third thing is, if you have 3 degree alcohols, right, like this, if this is your alcohol, now with 3 degree there is no scope, you can't have a double bond here, right, because already it is having 4 bonds. You can't replace this hydrogen and make a double bond here, so there will be no reaction here, right? So what you have to understand, that with 1 degree, it is firstly going to form aldehyde, then it is going to form carboxylic acid, right? Carboxylic acid. With 2 degree, it is going to form ketone, right? That's it. With 3 degree, there is no formation, right? Now let us talk about what are the mild reagents, mild oxidizing agents, and what are strong oxidizing agent. So if we talk about alkaline KMnO4, that is a strong oxidizing agent. So it will behave like this one. So it will convert 1 degree to carboxylic acid, 2 degree to ketone, right? That is a strong oxidizing agent like KMnO4, alkaline KMnO4, or K2Cr2O7. This is your strong, right? This or K2Cr2O7, right? These are your strong oxidizing agents. Then there comes Jones reagent. Now this is also very important, right? What is Jones reagent? Firstly, let us see. Is this a strong? Yes, it is a strong oxidizing agent. It is a strong oxidizing agent. Oxidizing agent. Strong oxidizing agent, that means 1 degree to carboxylic, 2 degree to ketone, right? So Jones reagent, what is this reagent? That is consist of chromium trioxide CrO3 in sulfuric acid dissolved in mixture of acetone and water, right? CrO3, aqueous H2SO4 and acetone. This is together is called the Jones reagent, right? It is a strong oxidizing agent. Okay, when you talk about PCC, PDC, they are mild oxidizing agent. They are mild oxidizing agent. Mild oxidizing agent. What about these mild oxidizing? This is pyridine chlorochromate, right? CrO3, HCl pyridine, right? Okay, what is PD? PDC, pyridine dichlorochromate. That is your PDC, right? So these are mild oxidizing agent. They will convert 1 degree to aldehyde and 2 degree to ketone. With 3 degree, they will have no reaction. 3 degree, they will have no reaction, right? What about, this is the structure of PCC, PDC, right? You can go through this structure, right? You can go through this structure, right? What is PCC? This is basically your PCC, right? Pyridine, this is pyridine. This is chlorochromate, right? This is chloro, C double bond to C double bond and chromate, right? Okay. And what is PDC? This is a pyridine dichromate, that is your PDC, and this is your PDC, right? Okay. This is your PDC. Now, next is how they behave. As you can see, PCC, PDC are weak oxidizing agent. They will convert, if this is your, this carbon is converted, this is basically 2 degree. Because here the carbon is connected to 2 more carbons. So it is a 2 degree alcohol. What about this one? Here carbon is connected to only 1 carbon. This is 1 degree. This is 2 degree. 2 degree will be converted to ketone. 1 degree will be converted to aldehyde. Right? So that becomes your correct answer. Right? Okay. Next is very, very, very important. Copper heat at 573 Kelvin, or you can say 300 degrees Celsius. Now, what is this? A mild oxidizing agent? Is this a strong oxidizing agent? So for 1 degree and 2 degree, if you talk about 1 degree, if you talk about 2 degree, and this is 3 degree, this is very interesting because it also gives a reaction with 3 degree, right? Okay. God, yaar. Such stupid people are here. So 1 degree and 2 degree, it will behave as a mild oxidizing agent only. That is for 1 degree and 2 degree, it will give us aldehyde. For 1 degree, it is going to give us aldehyde. It is going to give us aldehyde. 2 degree, it is going to give us ketone. 2 degree, it is going to give us ketone. For 3 degree, it is going to give us alkene. Now, this is very, very, very important, right? That for 3 degree, it is going to give us ketone, right? For 3 degree, it is going to give us ketone. Ketone, I am saying for 3 degree, it is going to give us alkene, right? How it is going to give us alkene, ma'am? Can you please answer that? Okay. So, you have CH3, you have CH3, you have CH3 here, you have OH here, right? And this is your copper, right? Now, what will happen here? This OH negative will replace from this side, and here you will have CH2 and H. What will happen? One H positive will be liberated here. we will take out this H positive, and these electrons will shift here, and hence you will have the formation of, this is C, this is CH3, this is CH3, this is double bond, this is CH2, and hence with copper you will have the formation of alkene, right? You will have the formation of alkene. Don't worry, I have a good ignoring capacity, right? YouTube has taught me that. So guys, let's focus here, okay? Just ignore this person. From tomorrow, you will not see such nonsense people on this channel, right? Now you have copper, as I told you, with 2 degree you will have ketone. With 3 degree it is going to form the alkene, right? Okay. Next is, ma'am, very important, that is your MnO2. Why? It is also a different oxidizing agent. It is only and only going to oxidize allylic and benzylic 1 degree, 2 degree alcohols. That's it. What is allylic? I told you in the starting, right, that you will use this allylic and benzylic somewhere. So allylic means C double bond C when you have this kind of alcohol. This kind of alcohol, that is your allylic. What is benzylic? When to this benzene ring you have a carbon that is connected to OH. That is your benzylic. This is allylic, this is benzylic, right? So here MnO2 selectively oxidizes OH to allylic and benzyl. Selectively oxidizes only these 2 alcohols. For example, now students see, this is OH. Here it is connected to a carbon which is further connected to a double bond. That means this is allylic alcohol. So it will oxidize this to aldehyde, right? Okay. Now, and it will oxidize to aldehyde and ketones. Okay. Also remember that thing. Here, this is your benzene ring, and a carbon next to it, it is attached to that OH. It is attached to that carbon. That means this OH is attached to that carbon which is further attached to a benzene ring. This kind of situation. So this is a benzylic. Like this is your allylic. This is your benzylic. Benzylic, and here you will convert this COH to C double bond O. Right? Okay? Right? Understood? Now, let us see one question based on this. Right? Well, we will do that after. I'll see if I put one question based on this. Chalo, no issues. After this, we are going to do questions only. Right? Now, dehydration reaction. That was all about oxidation. Right? I'll see if I can find that question. Right? Just give me a minute. Yes, this is the question, right? Okay, let us do this question because it is related to that concept, right? Okay. Okay, students, let us see this. So now here, everybody in the chat box, now here what you have, 2 alcoholic group you have. This is first one, this is the second one. Now, if you talk about this OH, it is connected to that carbon which is connected to a double bond. So, can I say this is my allylic alcohol? Right? What about this thing? What about this thing? Here, this OH is not attached to any allylic carbon, any allylic species. So, this is not allylic. This is not allylic or benzylic. That is why this reagent MnO2 will not do anything to this OH, but it will reduce this OH because it is a 1 degree alcohol. It is like 1 degree, so it will reduce it to 2 degree. So it will reduce it to aldehyde, right? So here, this CH2, it will be reduced to aldehyde. Basically, this straight line means this is the bond here, okay? Wait a minute, let me show you that. what is these lines, printing mistake it is, okay. A very, very important question this is. H, oi hoi, H, this is H, double bond, this is O, right? So now, as I told you, this will stay as it is, but this will be oxidized to CHO. So C will become the correct answer, right? C will become the correct answer. Okay? Don't worry, stories for you. I'm used to of these things, right? I've been teaching on YouTube for a long time, so I'm used to of this thing, right? I know the students who actually want to study, they will see if I am able to connect with this teacher, I will study. If I am not able to connect, I will study from somewhere else. They will never ever, type something bad for the teacher, right? But if you see students who are typing this and that for the teacher, they are not the genuine students. They are not even the students, right? Because they're like, oh, you are the only chemistry teacher in this universe. Why you're not teaching me? Why I'm not able to make a bond with you? No, that's not possible, right? It's about the connection. I truly believe that some students, maybe some will be able to connect with me. Maybe some of you might not be able to connect with me, right? Some of you will like the way I teach. Some of you will not like the way I teach, right? So I am not saying that I am the only chemistry teacher. I am here to teach you, right? If you really like the way I teach, right, then you can join, because I know I have full confidence on my content, right? If you're like, ma'am, if genuine feedback is there, if some genuine feedback is there, I'll definitely work on that. If some stupid random comments are there, I'll just like, what these kids, yeah, why you're so free? You are JEE aspirants, right? You should not be that free, right? So it's a huge competition. Even I am from a non-medical background, right? I know the huge competition. 10 years back, the competition was really, really high. But now the competition is even more high. The reason being because you have good YouTube teachers that are teaching you. Even the student who is studying there in some village, he has access. I am from a very small city, right? In my city, I don't have any coaching institute even now. Right? Even now, there are only private tuitions, right? Only private tuitions, right? Only school teachers are there to teach us, right? So, when I got out of my city for my graduation, for my post-graduation, I saw that the students who belong to big cities, they have so much, right? I didn't have anything like that, right? Because of that, I could not pursue my dream of becoming an engineer, right? So that's the problem with students who are born in villages and small towns. That's why I thought of becoming a YouTube teacher, right? That is my first inspiration that, yeah, this is like nice. You can connect with so many students throughout YouTube. You're teaching them for totally free of cost. If their financial background is also not right, you can teach them, right? So that was my main motivation. So I can totally feel you guys, right? I can totally feel you guys. Okay. Thank you so much. Thank you so much. Now, let us see the dehydration. So many other reactions are there. Chalo, let us see the dehydration. What is dehydration? As I told you, KOH with alcoholic QH will cause dehydration, but there is specific temperatures for that, right? Okay, thank you so much, students. Right, ma'am, can you say a quote that can motivate us at this moment? I don't really know any quote right now. I can't recall any quote, but I can just tell you one thing at this moment, that just jump into this game, right? Just give your 100%. Whenever you feel demotivated, just look at your parents, right? You know, it takes just one person to change the situation of their family. With education, there are 2-3 things that can change the situation of your family. Either you do some business, some really good business, right? Or you can be a good dancer, singer, you can become a big singer, you can become an actor, cricketer, something like that. If you don't have those talents, right? If you don't have a good business mindset, right? You don't have no investment to invest in that business. What is the last thing that can make you rich, that can make your financial situation really good, right? Not only your parents, your kids, your siblings, all of them, right? You can do that. How? By studying hard, right? It is no investment is needed here. Your brain is the investment here. So invest your brain into it. Your hard work is the investment in this, right? And only you, it is dependent on only you, right? If you make it, you will be able to change so many things around you, right? Otherwise, things will remain the same, right? So I think for me, that is the biggest motivation. Whenever I feel motivated, I just look at my parents and see, no, I can't give up, right? So same thing is applied to just look at your parents, the dreams in their eyes for you, and just go for it. Okay? Yes. Okay, now. Yes, beta, definitely the crash course is enough, but please do the DPPs, everything that teachers are telling you, do that. Only crash course is only beneficial if you practice, if you do the DPPs, the questions given by teachers, right? If you give the mock test, right? These things are important, right? Okay, now let us look at this. So here, basically, what is the temperature that you will need here, right? So, for example, they are saying, for example, you have 1 degree alcohol. For 1 degree, where is the temperature? Wait a minute. This is 2 degree alcohol. This is 3 degree alcohol. Yes, this is the temperature. Primary alcohols are, now why I am telling you the temperature specifically? Right, why I am telling you the temperature specifically? Can you tell me why I am telling you the temperature specifically? Because with the temperature, what you will have, at 433 Kelvin temperature, you will have the formation of alkene. But if the temperature varies, you will have the formation of ethers. Right, that we will do in the preparation of ethers. That's why I am telling you, specifying this thing, that the temperature is very important. When you have primary alcohol, the temperature should be, wait a minute, okay. No KOH here. So sorry. KOH, wait a minute. So sorry about this. KOH, alcoholic KOH, is not for alcohols to alkenes, that is for alkyl halides to alkenes, right? That is if you have RX, if you have alkyl halides, if you want to convert it into alkenes, then you use alcoholic QH, not here, okay, not here, my bad, right, not here. Here you will not use alcoholic QH, right, okay. What here you will use? Here you will use catalysts such as H2SO4, which is a very, very good dehydrating agents. You need good dehydrating agents, and the good dehydrating agents are H2SO4, H3PO4, right, anhydrous alumina. All these are good dehydrating agents. Now, if you're talking about 1 degree, you will need 433 to 443 Kelvin temperature. If you talk about 2 degree alcohols, what is the temperature that you should have? For 2 degree alcohol, the temperature should be 440 Kelvin. And 80% of H2SO4 will work it, right? If you have 3 degree alcohol, then you need even lower temperature, that is 358 Kelvin. Do you know the reason behind that? The reason is because in dehydration, you will have the formation of carbocation. And we know that 3 degree is more stable than 2 degree than 1 degree. So that is why in 3 degree, you have less harsh conditions. You have only 20% H2SO4. You have 358 Kelvin temperature. But when we talk about 1 degree, in this case, you have temperature is even high, even concentrated. It is 100% concentrated H2SO4, right? But in this case, you have 85%. In this case, you have 20%, right? So the concentration and the temperature also is important for you. Next is formation of protonated alcohol, right? So how it is formed? This is the mechanism of this. So again the same thing. It will attack here. You will have the formation of H2O. Now, sometimes things happen, right? Funny things happens, right? Yes. So now this electron will jump here and hence you will have the formation of this carbocation, right? This carbocation will be formed and after that there will be liberation. You will have the elimination of this H positive also. H positive will eliminate from this side. This double bond will jump to this side, right? Basically this bond will jump to this side as pi electrons and hence you will have the formation of alkene here, right? Now what is Sedgwick rule? For dehydration, right, there are different alkenes that can be formed. For example, if you talk about this one, I am saying that the OH is attached to the alpha carbon, the carbon next to it is beta. But here you have two beta carbons. That means two beta hydrogens you have. OH will be liberated from, not liberated, eliminated. I know why I am saying liberated again. OH will be eliminated from alpha only. But from beta, you have two choices. You have beta and beta dash. This beta and this beta dash. If it is eliminated from beta dash, if hydrogen is eliminated from this side, you will have the formation of CH3, CH double bond this. If the hydrogen is eliminated from this side, then the double bond will be formed here. That means you will have the formation of CH2 double bond CH, CH2, CH3, right? Now the problem is which will be the major product. So what Sedgwick told us that alkene will be formed which is more alkyl substituted, right? So in this case you have two alkyls. In this case you have just one alkyl that is substituted in this double bond. That is why highly substituted alkene is your major product, right? That will become your major product. This is your Hoffman product. This is your Sedgwick product, right? Hoffman product is your minor product, right? Now let us talk about these very important questions, right? Very important questions, everybody. Very important questions. So the first is going to be, you have CH3, this is OH. Very important. That means here what we are doing, we are adding acid here, right? Acid we are adding and then heating it. Basically we are doing dehydration. Okay, shall I write this? Shall I write this here? Okay, I am going to write this here. This is your benzene, right? This is benzene, not benzene, this is cyclohexane, right? Then you have CH3 and OH. CH3, this is a very beautiful question, okay? It's not directly you will tell the answer, ma'am, no, it's very easy. No. So many things will happen. Why? Because the main important thing about this reaction is that there is formation of this carbocation. That means rearrangement is also possible. Wherever you will see the formation of carbocation, there will be possibility of rearrangement. So here we can see rearrangement, right? We will see if it is possible or not. Now I know that from this alpha position, OH negative will be eliminated, right? Hence you will have the formation of this thing. This is CH3, this is CH3 and this is your positive, isn't it? Right? Now that will be, ma'am, please tell PDF is available or not. Yes, the PDF is available after the session. That is available on your official channel of Vedantu JEE English. Okay? Yes? Yes. Thank you so much. Don't skip in future for this comments, ma'am. Yes. I will not skip. Don't worry. Right? So now this is your carbocation. Now see this. This is the carbocation. Is there any chance of any rearrangement? If I talk about this thing here, this is your 2 degree. Because this carbon is connected to 2 carbons. So this is 2 degree carbocation, isn't it? This is 2 degree carbocation, isn't it? Now, what we will see, can I do the rearrangement? How, ma'am? How can you do the rearrangement? If I shift this hydride, not hydride, if I shift this methyl, now I will tell you a simple thing about hydride and methyl shift. Happy me. Happy me. What is happy me, ma'am? The order is happy me. Right? Firstly you have hydride, then phenyl, then you have methyl. Right? Because here we don't have any hydrogen, we don't have any phenyl, that is why methyl is the only option. So this CH3 negative will shift to this side and hence you will have the rearrangement which will look like this. This CH3 over here will stay as it is. Now what is the change that you will see? You will see one hydride has shifted here and now one hydrogen was already there and now this, because to this side one, not hydride, why I am saying hydride, one methyl has shifted, methyl shift, right? One methyl has shifted here, so you will have the positive charge here. Now what is this? This carbon is connected to 3 carbons. So can I say this is 3 degree carbocation, right? This is 3 degree carbocation, right? So now that means if I have to eliminate hydrogen, I will eliminate it from this carbocation. This is my carbocation. Either my, now there are also 2 choices. This is the, now what is my carbocation? This is carbocation. Either from this side the hydrogen can be eliminated, right? From this side we can eliminate hydrogen, or from this side we can eliminate hydrogen, right? Now there are 2 choices. Either from this side, if from this side it is eliminated, the answer will be, this is your cyclo, this is CH3, this is double bond and this is CH3. This will be formed. Or the hydrogen can be eliminated from this side. If the hydrogen is eliminated from this side, the answer will be, this is CH3, hydrogen is eliminated from this side, so here double bond will be present on this side. This is CH3. Now tell me, which is more substituted? This alkene has this one, other thing this, and this thing, right? Basically this whole thing, right? This alkene has first substitution, second substitution, and this is the third substitution. So more substitution is present in this thing, right? So that means this is going to be the major product. And this is going to be the minor product. This is going to be the minor product. Understood or not? This is going to be the major. This is going to be the minor. Now students, tell me, is this thing clear to you or not? Yes, is this thing clear to you or not? Is this thing clear or not? What we did here, firstly we saw that what is the carbocation that we should form, right? OH will be eliminated here, this carbocation will be formed. Is there any rearrangement possible? Yes. Now from this, there are 2 choices. Either this hydrogen can be eliminated or this hydrogen. I made the product of both of them. I know this is more highly substituted, that is why this is my major and this is my minor. You're like, ma'am, what you have done here? What are these snakes that you have formed? So I'll just write directly, this is my minor, this is my minor, and this is my major product. Major product. Now tell me, is there any doubt in this question? Right? Okay. Is there any doubt? Okay. Yes, Geeta. What we did here, OH negative will be eliminated, carbocation will be formed. Then methyl shift will happen here. CH3 negative will shift to this side. Here you will have the positive. Now either from this side beta hydrogen can eliminate, either from this side. Now from both, if I eliminate from this side, there will be double bond on this position. If I eliminate from this side, there will be double bond on this position. So in both cases, what is my major product? This is more highly substituted, so this is my major product, right? Okay. Yes. Okay. Now that this is that is my major product. Benzene CH3 double bond, that becomes my major product. So D is the correct answer, right? Next is, this is the same thing that I told you, they have written here. Now next is, when you have H2SO4, now very very important reaction. This involves ring expansion, ring contraction, right? Okay, this will involve ring contraction, ring expansion, ring contraction. So this is your CH2OH. Now these kind of questions are not asked in NEET. They are mostly asked in your JEE, right? Okay, very rare chances that they will ask you these kind of question in NEET. But in JEE, yes, right? So you have CH2OH. Now I know that when you do the dehydration, OH will be eliminated, right? So you will have the formation of this thing. That is CH2, this is positive, right? CH2, this is positive. You know what will happen now? You know what will happen now? Now, what will happen here? Everybody, what will happen here? Now, this is your CH2 positive. Now, very important thing, very important thing. This CH2 positive, students, there are two things, ring expansion and ring contraction. So, whenever your positive is outside the ring, there is ring expansion. Whenever your positive charge is outside the ring, that is ring expansion, okay? When your positive charge is on the ring, for example, something like this, then it is a case of ring contraction, right? So, because my positive charge is outside the ring, so ring expansion will happen here, right? So, what I will do, very simple trick for this, very simple trick I am giving you, right? Very simple trick. Right, very simple trick I am giving you. Very good. 6-membered ring will be formed. How this will be formed? Very simple trick. This is 1, this is 2, this is 3. Then how we can write 1, 2, 3? This carbon where you have positive charge, that is 1, this is 2, this is 3. Now what you will do? A simple thing. You will write everything as it is. Firstly write everything as it is. Then I will tell you what to do. Right, firstly write everything as it is. Now, break the bond of 2 and 3. Okay, ma'am. Break the bond of 2 and 3. Join 1 and 3. Join 1 and 3. Break the bond of 2 and 3. Join 1 and 3. And to this second, you should have the positive charge. To this second, you should have this. To this second point, you should have the positive. Always, that is going to be the trick. Anything you talk about, anything. I know that my 6-membered ring is more stable than 5-membered. That is why expansion has occurred here. Right? So, always, 1, 2, 3. Break the bond of 2 and 3. Join 1 and 3. Then this positive charge is shifted to 2. Okay? Positive charge is shifted to 2. Shifted to 2. So, now what is this basically? This is nothing but this is a 6-membered ring. 1, 2, 3, 4, 5, 6. This is basically a 6-membered ring where on the ring you have this positive charge. This is the ring that you have, right? Now you just have this hydrogen that will be eliminated. Both the sides are symmetrical. So hydrogen will be eliminated here, bond will shift here, and hence in the end you will have this kind of answer, right? This kind of answer you will have in the end. Okay, students, this kind of answer you will have in the end. That will become your, okay, that will become what? This one. Yes, this one. C is the correct answer. Right? C will become the correct answer. And I can tell you, students will mark A as the correct answer. Right? Because they will be like, ma'am, this is the carbocation that is formed. And here, this to this hydrogen, this will eliminate and it will make a double bond here. But actually, answer is C. Why? Because of ring expansion. Because of ring expansion. That is the difference between this is what we call the level of JEE. Right? Okay. So, small concepts are applied here. Right? Okay. This is, ma'am, this is so simple cramming I can do. Dehydration. But now this is something that you need to understand. This is conceptual knowledge that you need to know. To have like, if you want to be expert in organic chemistry, you need to have the knowledge of these things. rearrangement, ring expansion, ring contraction, right? And for that I have already told you simple direct trick on this, right? Okay. Okay. Yes. Now, next question is, okay, next is also a good question, that is the order of reactivity of falling alcohols towards concentrated HCl. If you talk about concentrated HCl, what is the order of reactivity towards it? Right? What is the order of reactivity towards it? What is the order of reactivity towards it, everybody? What is the order of reactivity? As I told you, if you want to tell the order of reactivity of falling alcohols towards concentrated HCl. In concentrated HCl, can you tell me what is formed? We did it in this is where. Now you'll ask me, ma'am, how they ask the mechanism? This is how they ask the mechanism. For concentrated HCl, we saw in the mechanism that there was formation of carbocation. That means they are asking you the stability of carbocation. They are not directly asking you the stability of carbocation, they are indirectly asking you the stability of carbocation, right? So this is how you will apply the mechanisms here. So instead of this, you will just write this is basically a big positive here, a big positive here, a big positive here, a big positive here. Now, which is the most stable carbocation? This will have, this is your phenyl, right? This is CH2 positive. Now, this is a good resonance. This is having a good resonance. So, this will be very stable. So, your fourth is very stable. Then, this is having 2 alkyl group that is donating. This is having electron withdrawing group, fluorine. So, that means after fourth, third is the next stable thing. Because if you have electron withdrawing group, if you are talking about a carbocation, which is money, if you take out money, electron withdrawing group, it will be unhappy, unstable. If you give the money, if like someone is very poor, you give them the money, they will be happy after that. So they will be happy. That means they will be stable, right? Okay. So now that means electron donating group are increasing the stability. Now in this case, what you will have? In this case, what you will have basically, if I want to write the full diagram here, it will be something like this. Okay, it will be something like this. I'll erase this after some time. But right now, just let us draw the diagram here. This is positive. Oh, such a big positive charge we have. This is positive. This is positive. Right? What is the difference here? Here, electron withdrawing group is very near. Here, electron withdrawing group is far. If someone is, you are positive, if someone is taking money from you, you are very poor, you only have 20 rupees in your account. And someone is, some scam is happening on your phone and someone is taking that 20 rupees. What the hacker will do with that 20 rupees, right? Okay, so now you have only 20 rupees, someone is withdrawing that 20 rupees from you. So more, the far away that person is, more safe you are. So now this fluorine is far away. This is 2 carbons away and this is just 1 carbon away. That means second is more stable as compared to first. So this will become the order. Order is 4, 3, 2, 1. So C will become the correct order here. Right? C will become the correct order. Okay? C will become the correct order here. Right? Okay? Can we tell the stability, on the basis of rearrangement only we tell the stability now. Next is an unknown alcohol is treated with Lucas reagent to determine whether alcohol is primary, secondary or tertiary. Which alcohol react faster by what mechanism? Okay. Now, if you talk about that fastest reaction, that means we are talking about tertiary. Tertiary is here and here. So, tertiary is reacting by SN1 or SN2. Tertiary, right? It is carbocation is very stable. That is why it will react through SN1 mechanism where carbocation is formed. So, it will react by SN1 mechanism, right? See how concepts are interlinked to each other. They are asking about Lucas, but you are talking about this carbocation stability. Right? This is why organic is so beautiful. I to love this about organic that so many concepts, you feel very happy when you're able to solve the questions, right? That is why I tell you that organic is not something to be scared of. Organic is just interconnected to each other. You should have a way to understand that, right? Okay. Now I'm talking about weightage, not syllabus. What was the question? Ma'am, give timetable for us to get 99% is 2 months. Okay, I didn't answer for your question. I answered for Pranav's questions. Yes. So he was asking me, ma'am, when should we use rearrangement and ring expansion? Rearrangement you will use in open chains, right? And ring expansion contraction you will use in this way. If you have a ring where you have positive charge on the carbocation, right, on that ring, then you will use ring contraction. If you have a ring but your carbocation is outside the ring, then you will use ring expansion, right? So these are the two things. It itself is a very vast topic. Have you done ring expansion, ring contraction on this channel? Have you done? If not, then tell me. Yes. Now, next is, I think this though we have done only, dehydration. Dehydration can only occur by other two things. That is, if you have Al2O3 in 633 Kelvin, right, then also you will have the dehydration. These are the other two reagents to do the dehydration. P2O5 will also cause dehydration, right? Okay, understood? Now, next is this question. Here they are saying, you have this PCC product, PCC. PCC is mild or strong oxidizing agent. What kind of oxidizing agent it is? Mild or strong? Mild or strong? Pranav has no mind, dude. Pranav is mindless person. That is why he is not able to mind. Either he is some person who don't know anything about chemistry, but if is still here, right, just to do Eve teasing. This is also Pranav, Mr. Pranav, this is also Eve teasing. You see, when you are, when some girl is going on bus or some public transport, and you are just, it is not like you are talking this and that on chat. It's basically that some girl is going on bus, right, on any public transport or just traveling, right, and you are constantly saying, you're very cute, you're very cute, you're very cute. How uncomfortable that girl will feel. You're doing the same thing, same ditto copy, right? So this is a digital Eve teasing that you are doing, right? So I am not affected by it because I have, like, I am used to of this thing. I know what kind of mindsets we have, right? So that's why I'm used to of that thing. But the problem is that my kids, my students who really want to study, they are getting affected by that, right? So it is advice to you that stop this thing, because this is not something that you should be really proud of, right? If you're really a student of JEE, then if you're really a JEE aspirant, then you are doing this, right? You are just constantly from 2 hours, you're constantly saying cute, 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 right? So I'll tell you what cuteness is, right? Just relax, right? Just relax. Now, here you have, this is OH, this is OH. This is PCC. Now, PCC is a mild, yes, everyone has filled the chat with mild, ma'am, mild, mild, mild. Now, mild oxidizing agent, this is my OH is connected to carbon, which is further connected to only one carbon. That is my 1 degree alcohol. Here, OH is connected to that carbon, which is further connected to 3 carbons, so it is 3 degree alcohol. That means in this OH, what is the product? What is the product? In the product, this OH is going to reduce to aldehyde, that is C double bond O, right? And this will stay as it is. This will stay as it is. That means in the product, you will have only one OH. Only OH functional group. Only COH functional group? No, no. You will have both OH and CHO functional group. So D is the correct answer, right? You will have both OH and CHO group, right? Okay, so D will become the correct answer, right? This though we have already done. Now, very, very important reaction. Very, very important reaction. Pinacol-pinacolone rearrangement, right? Pinacol-pinacolone rearrangement. For advance, the concepts that I'm teaching you is enough, but the questions, I want to have more questions because I think that is not possible in today's lecture. But I'll take more questions because in advance, the question will define your level, right? The concepts will be same only. For example, they will give you some very complicated reactant. There will be so many things that will be happening in that. So at advanced level, question practice is more important, right? We will do that question practice, right? But the concepts that are teaching you is the same only, right? Okay. Now, previously, beta, this is your, previous means this one. Yeah. So this is your 1 degree and this is 3 degree. In mild oxidizing agent, 1 degree is converted to aldehyde. So here I have converted this CH2OH to CHO, right? But 3 degree is not converted to anything in mild oxidizing or even in strong oxidizing agent. So in the product side, you will have both CHO and one OH. Both function groups are present, right? Okay. Now next is pinacol-pinacolone rearrangement, right? Next is pinacol-pinacolone rearrangement. Now, firstly tell me, do you want to do the rest of the part today only, or do you want to do rest of the part in other part? What do you want to do? Because half of the chapter is still left, right? This much we have completed. These many slides we are still left with, right? Now tell me what you want to do. Yes. Yes, Ritvik, no issues. Is this okay? Now tell me. So, firstly, by the time you think about that you want to complete this today or what, I'll teach you what is pinacol-pinacolone rearrangement, right? So, what is pinacol rearrangement? Pinacol rearrangement is the acid catalyzed rearrangement of vicinal diol. What is vicinal, ma'am? Geminal is when on the same carbon you have two OH. That is called a geminal. What is vicinal? When on two or adjacent carbons you have OH. That is called vicinal. Basically, any group you have on the adjacent carbon, that is vicinal. Vicinal diols means you have two OH on the adjacent carbons, that is vicinal diols. Right? Okay? Very good. It's now new student. Hello, Dushyant. Thank you so much. Dushyant, thank you so much. That means a lot to me. Yes. Now, let us see acid catalyzed. That is why I take long lectures. You know the problem with me? The problem with me is that because I have explaining in detail. I see, even if I see one student who is writing in the chat box that, ma'am, please explain this again. I'm like, okay, I don't want that kid to feel like I am not focusing on that kid, right? I know that thing, right? I don't want any of you to feel like that. That's why that is the best thing also. I ask my students, what is the best thing about my teaching? They tell me, ma'am, even if a student who has no knowledge about chemistry, he or she will be able to understand because you teach in such a manner, right? Ma'am, what is the problem? The problem is, ma'am is explaining too much, then ma'am take long lectures, right? So that is the problem with me. But I tried not to take long lectures, but still I don't know how I am standing here for 5 hours, right? Chalo. Now, ma'am, stop telling you are teaching about 4 hours. Yes, you will definitely be my favorite. If you are a subject, you will definitely be my favorite. Thank you. That was a nice line. Okay, now students, this is a very important reaction and one of my favorite reactions. Pinacol-pinacolone rearrangement. The name is also very cute, like me. Okay, I just tease someone here. So this is pinacol-pinacolone rearrangement. Now students, see What is pinacol? What is pinacol? Ol, alcohol, colon, ketone, right? Pinacol, pinacolone rearrangement. Now this is a very important. What we will do here, first I will tell you directly what is the answer, then I will give you more examples for that, right? Firstly, you have pinacol. Pinacol are basically vicinal diols. That means two carbons that are adjacent to each other, both have one OH, that is called pinacol, right? Now with acidic, in acidic medium, what happens, right? Now, what will happen? This will get converted to a pinacolone. That means one of the R part will be shifted here and this OH will be converted to double bond O. That is called pinacolone, right? Why this is so important? Because, and this reaction is asked as it is, right? If they ask you this question, they will ask you as it is, right? Okay. Aren't you tired? I am a little bit tired because as I told you, I have viral. So that's why my tongue is, my mother tongue is like, my throat is paining right now, little bit, right? But I want to complete this at least this pinacol, pinacolone, right? Ma'am, what factors migrates rearrangement does affect the stability of carbocation intermediate? Yes, what are saying, we will study about everything, but see, firstly, let us see the mechanism here, right? Now, here the mechanism is important. Why? Here the question that they will ask you will be direct questions, right? So, I am not looking into the chats now, I am just looking into the board now. Now, everybody focus on the board, okay? Focus on the board. So, you have two ols. You have two alcohols, right? Two ols here, diols, vicinal diol you have. Now, we are doing this from the starting of this chapter. Okay, there is this H positive which is electron deficient. There is this oxygen which is electron rich. This H positive is going to say hello to this OH. Be like, okay, you have O, you have lone pairs and I am very electron deficient. You are electron rich. So, please, can I come to your home? So, you're like, okay, you can come here. Then what OH, what oxygen observed, that oxygen is the same thing. First, he will say, hi, hydrogen, you can come and live at my place. Then he'll be like, oh my God, hydrogen is taking away my space. He'll be like, hydrogen, you can get out of my life, right? So, this is the same thing they will do, right? First, he will say, hi, hydrogen, you can come into my life, right? So, hydrogen is in its life. This has become OH2. But now, oxygen felt that I am positive now. What should I do? Now, I want to have some electron from somewhere. So, it will try to take out the electrons from here and hence you will have the formation of this carbocation, right? This carbocation. Now, this is not a usual rearrangement. This is a pinacol, pinacolone rearrangement. Now, what will happen? This was already a 3-degree carbocation, right? 3 carbons were connected to it. But now, what will happen? This will replace this 1R, or you can say this, there will be methyl migration here, right? How methyl migration will be present? This CH3 group, right? This CH3, any of these group will be migrated to this side and hence you will have the positive charge here. This CH3 negative will be migrated to this positive here, right? And hence you will have the formation of, this is CH3, 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 CH3 and this becomes your C. Now this is very important. Now you can just skip this thing. You can skip this thing because they are interchangeable to each other, right? What I would advise you, from this you can convert this. Here you will have the formation of this carbocation. Because this methyl has been shifted to this side and hence this carbon is now electron deficient, it will have a positive charge here. Now what will happen? This will donate the lone pair here, right? And hence it will become double bond. This is O, this is positive, right? Firstly, you should make this thing, then you should make this thing, right? This is what will happen. This methyl, again I am telling you what will happen. H positive is going to attack here. OH2 will be formed. Oxygen cannot handle positive charge, so water will be eliminated, right? Minus water, it will have the formation of this carbocation. Then this methyl, from the other carbon which has OH, from that a group will be migrated to this carbocation and now this carbocation which has a OH bond, the lone pairs are going to shift the electrons here and make a double bond here, right? And hence this will have a positive charge and it will keep changing to one another. Now in the end, what will happen? This H positive, this H, when from this to this, after this you will have the formation of this, right? Wait a minute. Yes. After this you will have the formation of this methyl shift. Then from this H positive will be eliminated and the electrons will jump here and hence you will have the formation of this pinacolone, right? And hence you will have the formation of this pinacolone. Shall I tell you again what we did here? Everybody, this is your vicinal diol. Whenever you will have vicinal diol in acidic medium, firstly that H positive from the acid will attack on the lone pairs of OH. You will have the formation of OHO. Oxygen having positive charge is not stable. Water will be liberated here. Water will be eliminated here, right? Hence you will have the formation of this carbocation. Then any methyl group or any phenyl or hydrogen, anything will be shifted here. Here I have methyl group only. So I have shifted this methyl group to this side and hence I'll have the formation of carbocation here and OH here. Then the lone pairs will be shifted to this carbocation and you will have a double bond and this is OH. Now oxygen is again positive. So it will take out the electron from this sigma bond and hydrogen will be eliminated and hence you will have the formation of pinacolone, right? I understood it very well. Very good. Very good. Now, one of the student was asking, ma'am, how the migratory aptitude is affecting this. Now, here to I was talking, I have given you all CH3, 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 all of them are CH3. Now, if they complicate this thing, right, this is basically going towards JEE advance, right? So, now, for example, they have given you PH, PH, CH3, CH3. First question in your head will be, should this H positive attack on this OH or this OH? If I am taking this as A, this as B, right? It should attack on this OH or this OH. If it is attacking on this OH, then the formation will be, you will have the formation of this carbocation, right? This carbocation which is having 2 CH3. But if I say that it is attacking on this OH, right? Then you will have the formation of this carbocation. Now tell me which carbocation is more stable, right? Thank you. You're like H positive because you have to leave always. Oh my God, that's a very good thing, right? Thank you. You're like a chiral molecule. You make everything around you more interesting. Thank you, Sai. Thank you. I think I am teaching you chemistry really well, right? That's why you are like completely deep diving into chemistry. You're like, ma'am, we can make even memes out of chemistry, right? We can make ma'am memes also. Are you a reaction mechanism? Because I would love to follow your steps. I am not dancing. Okay, sign, control. Now, Sai is my very old student, right? So, now this is positive, this is phenyl, this is phenyl. Now see one thing here, this phenyl, this is my phenyl, right? This is carbon and this is again phenyl, right? This will be more stable because it will have resonance, right? Everybody focus here, right? Everybody focus here, please, right? Focus here, right? Now, this positive is more stable. Why? Because of resonance rather than if you have positive over here. That is why I am saying that this H positive is going to attack on this OH, right? Okay, I am not going to draw the arrows. If you draw the arrows should be like this. Arrow should be on this because arrows are always from more electron density to less electron density, right? So this OH is going to accept this H positive, right? Then it will form O positive H2, then that will be eliminated as water, and hence you will have the formation of this carbocation. This carbocation will be formed, right? Now, ma'am, the next question is, this CH3 and this CH3, they should be migrated. Both are CH3 only, so I can easily migrate this CH3 here, right? So this CH3 will be migrated here, and hence you will have the formation of a carbocation. This is OH. Now, the lone pairs of this oxygen will be shifted to this side, right? And hence you will have the formation of which thing? You will have double bond. You will have basically something like this. PH, PH, this is CH3, this is C, this is double bond O, this is H, this is positive, this is CH3. Then this H positive will be eliminated, the lone pairs will be shifted in, and hence you will have the formation of this pinacolone, right? Yes, there are definitely rules, but right now I am not doing that question where you are going to apply the rules. Here the question was which carbocation will be formed, but no migration was, there was no choice of migration because this is also CH3, this is also CH3. But now I will see one more reaction. Wait a minute. Wait a minute. Wait a minute. Yes. This is that reaction. Okay. One more reaction. Now I will have that choice or not. No, I will not have that choice again. Right. I will not have that choice again. So basically, students, if you want to know the rearrangement, it will be happy me. Happy me. So if you have a choice here that, for example, I had phenyl and I had CH3. In that case, I would have shifted phenyl group here, right? For example, in the next page, if I copy paste this thing here, if I copy paste this thing here, if I copy paste this thing here, if I say that here you don't have CH3, instead you have phenyl here, then what would happen? If you had phenyl here, then what would have happened? Right? If you had phenyl here, then what would have happened? Let us see that. Okay. Now, I am saying if you have phenyl, this is phenyl. Right? Phenyl. pH. This is pH. Now, there was a choice. Then what I should migrate? pH or CH3? So pH will be migrated, and hence here you will have pH, here also you will have pH, answer will be pH, right? Here also you will have pH, right? Because after this, what you will be left with? After pH you will be left with CH3, and the pH will be migrated here, right? And the pH will be migrated here. So basically, what is the rearrangement? It is like this. Happy me. HPM. That is the migratory aptitude, right? That is for rearrangement or pinacolone rearrangement. It is the same thing, right? Okay. Is that clear? Is that clear? Bus, Sai, Dheeraj, control your emotions, right? Now, that is the answer for this. Now, let us talk about one more question based on this, right? That is this one. That is your, which carbonyl compound is main product of the following diol? If you talk about the following diol, they are asking you which is the main product here. Main product they are asking you. Main product, yes. Now, it is a vicinal diol. We can say this is a pinacolone rearrangement, right? Okay, yes. No, this is basically how the migratory aptitude is given to us, right? This is basically how the migratory aptitude is given to us. That is why I have mentioned you this product, right? Okay, yes. Now, next is this question, right? Now, Here first thing is which OH will be attacked here, right? Which OH will be attacked here, right? So now which OH will be attacked here? So I'm just erasing this thing here because I'm going to write the full mechanism here, right? Okay. Now what you will have, this H positive is going to attack on this oxygen or on that oxygen. On this oxygen, because of phenyl, more stable product will be formed. So here you will have CH3, right? CH3, not CH3, it is CH2, CH3. It is CH2, CH3, and this carbon phenyl is attached, and here carbocation will be formed. Then you will have this carbon, this is CH3, this is CH3. Now I know we have two CH3 groups, so one of them will be migrated, and hence you will have this CH2, CH3, this is your CH3, this will become PH, right? This is C, because one phenyl has been migrated, this is CH3, this is OH. Because of the lone pairs here, the lone pairs will be shifted here, then what you will have, the lone pairs will be shifted here, then what you will have, the lone pairs is shifted here, wait a minute, you will have this thing, right? What you will have, the lone pair is shifted, because of that, you will have a double bond here, and this is your H and this is your positive, because the lone pair is shifted here. Now, again what will happen, H positive will be eliminated, the electrons will be shifted here, and then what you will have this H positive will be eliminated, electrons will be shifted here, hence you will have the formation of this pinacolone, right? This is the answer. Okay, so that is CH3, PH, CH3, CH3, CH2, PH, CH3, yes. So D will become the correct answer. Okay, D will become the correct answer. Finally, we have completed preparation of alcohols, right? We are still left with phenols and ethers, right? Right, phenols and ethers, right? Students, in the next lecture, so we will do phenols and ethers only, right? So I will make one new session, right? Next lecture is going to be for alcohol, phenols and ethers, part 2, where we are going to do phenols and ethers. I am also going to take up some more questions, right? Do you want more questions in this session or just theory? What you want? I feel that question practice is also very important, right? Yes? Because I haven't done my syllabus, I only covered 40-50%. Please help me, ma'am. Dushyant, right now don't think about any drop, right? Right now don't think about any drop. That's my advice to you. Right now just think about that I have to utilize these 7-8 months, right? Okay. Firstly, focus on your JEE means, right? Then we will talk about JEE advance also. That's my advice to you. If you now think about that I'll take drop, for 5 months your energy will be really low, right? So utilize this thing, right? Okay. Thank you. Chal. Ma'am, we want PYQs in lecture. Okay, perfect. So I will also include PYQs in the lecture. In the next lecture, we are going to do some very, very important JEE means plus JEE advance PYQs, right? PYQs we are going to pick up, PYQs, and we are going to complete this chapter with phenols and ethers, right? For today, we have done like enough questions, right? So that you are able to understand what exactly kind of questions will be there in your exam, right? Okay, PYQs. Definitely, Dinesh, Nanda, yes. So we will definitely include PYQs in the next session as well. Right? Okay. Okay then students, bye bye, take care, see you all in the next lecture, but don't forget to hit the like button, right, so that even I can know that are you liking this or not, right? So this was my first lecture on Vedantu JEE English. If you have any comments, any feedback, anything, yes, I will work on the studio thing, right? Because studio, I know that is blinking in between. So I'll ask the team and we will, this will be sorted, right? From the next lecture, it will be sorted, right? That is the first thing. Any suggestion, any advice, any appreciation, any feedback, if you have, then write it down in the comment section. And also write down those chapters that you want me to take up, right? And I'm talking about those chapters that you are not done on this channel, right? Firstly, write down those chapters that are not done on this channel, right? And that you have not completed yet. Firstly, our priority will be on those things, right? Okay, haloalkanes, halorines, yes, I have noted that. After alcohol, phenol, ether, I am going to pick up haloalkane, halorine only, right? Okay, yes. Okay. Okay then, bye bye, take care, see you all in the next class, and the notes will be provided on Vedantu JEE English Telegram channel. Till then, take care of yourself and keep smiling, keep spreading the love around you, and also keep commenting and spreading some appreciation in the comment section. Bye bye, take care.